Hi guys, I wish to take you through elementary programming principles, and therefore we shall start by defining terms that are used in programming. And the first one is a computer program. When you talk about a computer program, it is a set of coded instructions given to the computer and represents a logic solution to a problem. It directs a computer in performing various operations through tasks on the data supplied to it. Computer programs may be written by hardware manufacturers, software houses, or a programmer to solve computer-related problems. On the other hand, when we talk about programming, programming is the process of designing a computer program or computer programs which can be used to perform a particular task or solve a specific problem. It involves use of special characters, signs, and symbols found in a particular programming language to create computer instructions. Then we also need to check a computer program, how a computer program performs its duties, and therefore a computer program performs the following. It accepts data from outside the computer as input. It carries out a set of processes on the data within the computer. We call this processing. Then it presents the results of this processing as output. And then it stores the data for future use. That is now the storage. Therefore, we have the input, processing, output, and storage. Then we can go ahead and look at the programming languages. What is a programming language? Now, a programming language is a set of symbols or a language which a computer programmer uses to solve a given problem using a computer. The computer must be able to translate these instructions into machine-readable form, which that is when arranged in a particular sequence or order. Then we need to look at terminologies or terms used in computer programming. Basically, we have these terms. Number one, we have the source code. Other books will call it source program. What is a source code or a source program? A source program refers to program statements that the programmer enters in the program editor window and which have not yet been translated in machine-readable form. Therefore, when the programmer is typing his codes, we call those codes source program because they are not yet machine-readable. Then we have the object code. Some books will call it object program. Now, the term object code refers to the program code that is in machine readable, that is in binary form. That is to say, it has been translated now. It is the source code that has been translated from now the human readable to machine readable format. Then we have the next terminology is language translators. Just like the word translator goes, they are used to change one from one form to the other. That's why they are called translators. And therefore, a computer uses and stores information in binary form. And therefore, it cannot understand programs written in either high or low-level languages. We shall later look at the difference between high and low-level languages. This means that any program code written in assembly language or in high-level language must be translated into machine language before the computer can recognize and run these programs. Therefore, a translator is a special system software or just a program used to convert source code to object code. We have looked at source code and object code. Therefore, basically, the definition of a translator is a software that converts source code to object code. Then on the other hand, each language needs its own translator. You need to understand that every computer language as a programmer requires its own translator. Generally, there are three types of language translators. We have assembler, interpreter, and compiler. Those are the examples of translators. In case you are asked, state 3 examples of translators, then you give assembler, interpreter, and compiler. Then note, interpreters and compilers translate source program, that is source code, written in high-level languages to their machine equivalents. Then we can look in depth what is an assembler. Now, an assembler translates programs written in assembly language into machine language that the computer can understand and execute. Therefore, what are the functions of an assembler? Number one, it checks whether the instructions written are valid and identifies any errors in the program. Therefore, number one is error detection. Number two, it assigns memory locations to the names the programmer uses. Now, the names that programmer uses are called variables, and therefore the assembler assigns memory locations to variables, or rather, assembler assigns memory locations to the names the programmer uses. For example, the assembler keeps a table of these names so that if an instruction refers to it, the assembler can easily tell the location to which it was assigned. Then number three, it generates the machine code equivalent of the assembly language. Usually, the assembler generates a machine code only when no errors are detected. Some of these errors include typing mistakes, using the wrong format for an instruction, specifying a memory location outside the range. For example, you have a range of 0 to 2047, then you give 3000. That one will actually result to an error. Then you have the interpreter. An interpreter translates a source code or source program word by word or line by line. That means it takes a lot of time. It reads a line by line. This allows the CPU to execute one line at a time. The interpreter takes one line of the source code or source program, translates it into machine instruction, and then it is immediately executed by the central processing unit. Therefore, assembler translates assembly language to machine language. Interpreter translates, that is the source code, to machine language, line by line or word by word. Then we have the compiler. A compiler translates the entire or whole source code into object code at once. Therefore, you can see it takes a lot of time, it saves a lot of time because it actually takes the whole program, reads it, and translates it to machine readable form. That process is called compilation. Therefore, when you are using a compiler to compile a program, you are doing compilation. Then, what are the functions of a compiler? A compiler performs the following tasks during the compilation process. Point number one, it identifies the proper order of processing so as to execute the process as fast as possible. Therefore, it identifies the proper order of processing to save on space and memory. Number two, it allocates space in memory for the storage locations defined in the program to be executed. It allocates space in memory. Then number three, it reads each line of source program and converts it into machine language. It also checks for syntax errors. We shall look at the syntax errors later. It also combines the program generated with appropriate subroutines from the library. It produces a listing of program indicating errors, if any. Therefore, those are some of the functions of compiler. Then we can also look at the differences between compilers and interpreter. This is a very examinable part. Therefore, make sure you can identify. Number one, we shall look at the interpreter. On the other hand, we look at the compiler. And that is number one, number two, that way up to number five. Number one, interpreter. Interpreter translates and executes each statement of the source code, that is one at a time. We have said line by line or word by word. On the other hand, compiler translates the whole. We have said talk of the whole or entire, translates the source code statement at once as a unit into their corresponding object code. The source code instruction is translated and immediately obeyed by the computer hardware before the next instruction can be translated. On the other hand, a compiler translates the entire source program first to machine code. Number 2, interpreter translates the program each time it is needed for execution. Hence, it is slower than compiling. That means that whenever you run a program that has been interpreted, it has to be interpreted. That is a machine, that is when you run a program that has been worked on by an interpreter rather than a compiler, it must be executed every time. Whereas compiled programs can be saved on a storage media and run when required. Hence, you don't need to compile every time. That saves on time and makes it faster. Number 3, on the interpreter, interpreted object codes take less memory compared to compiled programs. On the other hand, compiled programs require more memory as their object files are larger. Therefore, this one requires less memory. Compiler requires larger memory. For an interpreter, the syntax errors are reported and corrected before the execution can continue. But for a compiled program, syntax errors are reported and corrected after the source code has been translated. Therefore, for the interpreter, it is before, for the compiler is after. Number 5, an interpreter can relate error message to the source program, which is always available to the interpreter. Whereas, on a compiler, once the source program has been translated, it is no longer available to the compiler. Therefore, you can see they both have advantages and disadvantages. Then we can look at linkers and loaders. When you talk about a linker, computer programs are usually developed in modules or subroutines, that is, program segments meant to carry out specific relevant tasks. If you are asked to define modules or subroutines, just say these are program segments meant to carry out specific relevant tasks. During program translation, these modules are translated separately into their object machine code equivalents. Therefore, let's see what is a linker and what it does, and also what is a loader and what it does. Now, a linker is a utility software that accepts the separately translated program modules as its input and logically combines them into one logic module known as load module. Therefore, the work of a linker is to accept or to link together separately translated programs into one logical module. On the other hand, a loader is a utility program that transfers the load module into the computer memory. Therefore, the loader just takes now the translated load module from the linker and saves it into the computer memory for use. Then we can look at the errors, that is types of errors. We have the syntax error. We have, that is, first of all, before we go to that, we can look at the syntax and semantic meaning, those terminologies. Then probably we shall look at the errors later. Now, syntax, when you talk about a syntax, refers to the grammatical rules which govern how words, symbols, expressions, and statements may be formed or combined. Therefore, syntax simply means grammatical rules that govern how a certain thing goes. Then we have semantics. These are rules which govern the meaning of syntax. Therefore, they actually govern the flow of the syntax. Then we can go ahead and look at the levels of programming languages. This is a different subtopic, levels of programming languages. There are two major levels of programming languages. We have low-level and high-level programming languages. Therefore, you have low-level programming languages and high-level programming languages. Each programming language has its own grammatical rules or syntax, which must be obeyed in order to write varied programs, just as natural language has its own rules for forming sentences. Therefore, let's start with the low-level languages. These are the basic programming languages which can easily be understood by the computer directly, or which require little or no effort actually for the computer to understand. We are calling them low level because they are very close to the computer language. But high levels are very close to human beings, so they are very far from computers. Therefore, when we talk about low level languages, we are calling them low level because they are very close to computer. And therefore, you have two categories. We have first and second generation, or machine language and assembly language. Those are the first and second generation. Therefore, you have machine language and assembly language. Therefore, we can also look at the features of low-level languages. They are machine hardware oriented. They are not portable. They use mnemonics. Mnemonics are symbols. They use symbols, and then they frequently use symbolic addresses. Therefore, those are some of the features of a programming language. Then let's go to the first generation of languages of computers. We have several generations. We have first, second, third, all the way to fifth, but we shall also be looking at them later. Therefore, let's start with the first generation of languages. That is generation of programming languages. We have machine language. Machine language is written using machine code, that is binary digit that consists of zeros and ones. The computer can readily understand machine code without any translation. A programmer is required to write the program in strings of zeros and ones, calculate and allocate the core memory locations for his data and its instructions. Therefore, you need to have that one. Then when we talk about a machine code instruction, it has two main parts. It has the address part and also the functional part. Then we can look at the second generation language, that is programming languages. We call them 2GR, or just say second generation language. You have the assembly language. Now, the assembly language were developed in order to speed up programming, that is, to overcome the difficulties of understanding and using machine languages. The vocabulary of assembly language is close to that of machine language, and their instructions are symbolic representation of the machine language instructions. Assembly language programs are easier to understand, use, and modify compared to machine language programs. Assembly language have less error chances. To write program statement in assembly language, the programmer uses a set of symbolic operations called mnemonics. Therefore, from this example down here, you can see how mnemonics are used. Therefore, subtract, like now, subtract PAT 10. That means subtract 10 from the value in register PAT. The other one is RD PAT 15. That means read the value 15 stored in processor register named PAT. That means you can see the word read, we have used RD. The word subtract, we have used SUB. Those are the mnemonics, use of symbols to represent something. Then we can look at the advantages and disadvantages of low-level languages. Advantages: the CPU can easily understand machine language without translation. That is one of the advantages. Number two, the program instructions can be executed by the hardware much faster because it actually doesn't need translation. Number two, Low-level languages have a closer control over the hardware, are highly efficient, and allow direct control of each operation. That is, they are therefore suitable for writing operating system software, game programs, which require fast and efficient use of the CPU time. Then the next point is that they require less memory space, and then they are stable. Therefore, those are the advantages. They are stable, they do not crash, they require less memory, they are close to the hardware, they are easily understood by the machine, they are also easily executed. Then what are the disadvantages? Now the disadvantages, very few computer programs are actually written in machine or assembly language because of the following reasons. Number one, they are difficult to learn, understand, and write. Number two, they are difficult to remove errors. We call the process of removing error debugging. A bug is an error. Therefore, those are some of the disadvantages that make it not actually good for use. They are also not portable. We had looked at that. Then we can go ahead and look at high-level programming languages as our second subtopic. Now, high-level programming languages, these are languages that are very close to human beings. Therefore, they use our normal languages like English. You can use English just like you can program using normal English. Therefore, these are languages that are very close to human beings, and therefore you say high level is very close to the vocabulary of the natural languages by human beings. Hence, they can be read and understood easily even by people who are not expert in programming. Therefore, what are the features? First of all, before you go to the features, compiler and interpreter are used to translate high-level languages. We had said that earlier. Then you can look at the features of high-level programming languages. Number one, they contain statements that have an extensive vocabulary of words, symbols, and sentences, and the mathematical expressions, which are very similar to normal English language. Therefore, you can look like this example here. Example, read tax payable. If tax payable is less than 100, then tax equals to 0. Else, if it's greater than 1,000, then tax equals to tax rate times tax payable. Then you write the product. Therefore, you can see now that is an example of high-level language that is very close to human. Then point number two, they allow modularization, that is use of small segments called subroutines. It allows modularization. Modularization is the use of small segments called subroutines or subprograms. They are user-friendly, that means you can interact with them without problems. They require that is to obey a set of rules when writing the program. Therefore, you have to follow certain rules. Programs written in high-level languages are shorter than their low-level languages. You can imagine writing the word read using zeros and ones. You write a lot of zeros and a lot of ones, but when we write it as word read, it is actually shorter. Then the programs are portable. You can carry them using a flash disk, using a CD, or send them via the network. Therefore, they are portable. Then purpose of high-level languages. Why did these programmers come with high-level languages? Number one, to improve the productivity of a programmer. This is because the source programs of high-level languages are shorter than source of low-level languages, since one statement translates into several machine code instructions. Therefore, number one is productivity. Number two, to ease the training of new programmers. We have said low-level languages were very difficult to learn, but these ones are easy. Therefore, this one make it easy for training of new programmers. Then, to speed up testing and error correction, and also to make programs easy to understand and follow. Remember, you have said they are user-friendly. Then, advantages of high-level languages. Number one is portability. It is portable. Then they are short, they're just like we had said there, they are easy to run, they are easy to debug, they are easy to modify, they are user-friendly, such they are more flexible. We had actually looked at those ones in the features. Then disadvantages, they are not machine-oriented, therefore they must be translated or compiled. The language are machine independent, that is, cannot be used in programming the hardware directly. Then each high-level language statement converts into several machine code instructions. This means that they use more storage space. Therefore, the disadvantage there is they use more storage space. Then on the other hand, their program statements are too general. Hence, they execute slowly than the machine code equivalents. Therefore, you can talk of the disadvantage there is execute slowly. They have to be interpreted or compiled to machine readable form before the computer can execute them. That is, they take a lot of time for preparation. Then we can look at the types of high-level languages. Types of high-level languages. Remember, so far we have looked at first generation, that is machine readable and assembly language, first and second. Then now we go to the third generation, that's where we start. Therefore, types of high-level languages. All high-level languages start from the third generation all the way, but the low level, we have first and second generation. Therefore, we have 5 different groups. We have third generation languages, which are also called procedural or structured. If somebody talk of structured languages, he or she is talking of third generation languages. Then we have fourth generation languages or 4GLs. We have fifth generation languages or 5GLs. We have OOPS, that is object-oriented programming languages. And then we have web scripting languages. The various types of high-level languages differ in the following: the data structures they handle, the control structures they support, the assignment instructions they use, and application areas. Therefore, those are some of the things that make them different. Then we can look at the structured languages or 3GLs, that is the third generation of languages. What is a structured program? A structured or procedural language allows a large program to be broken into small programs called subprograms, or you can also call them modules. Therefore, when you talk about a structured or a procedural, it means that you have broken down your program into small parts called subprograms or modules, each performing a particular single task. This technique of program design is referred to as structured programming, and therefore structured programming is breaking down a bigger program into small subprograms or submodules. Structured programming also makes use of few simple control structures in problem solving. The 3 basic control structures are the use, sequence, selection, and iterations. Later on, we shall look at the control structures, but for now, just know we have sequence, selection, and iteration. Then, what are the advantages of structured programming? Number 1, it is flexible. Structured programs are easier to read. Programs are easy to modify because a programmer can change the details of a section without affecting the rest of the program. It is easier to document, that is to write a documentation on it. Use of modules that contain standard procedures throughout the program saves development time. Modules can be named in such a way that they are consistent and easy to find in the documentation. Debugging is easier because each module can be designed, coded, and tested independently. Then we can look at the examples of third generation languages. We have BASIC in capital letters. BASIC stands for Beginners or Purpose Symbolic Instruction Code. That is one example. And therefore, BASIC is a simple general purpose high-level language used in most computer processing tasks such as developing business, educational applications, etc. Then we can look at Pascal. We have Pascal. Pascal is also written in capital. It is a general purpose high-level language which was named after French mathematician called Blaise Pascal. It was developed as an academic tool. Therefore, it is used in teaching and learning. That is Pascal. Then we have Combo or COBOL. That means Common Business Oriented Language. Therefore, it was created to solve business-related problems. Therefore, the best thing to know are the examples. We have Pascal, we have Combo, we have BASIC. Then we have Fortran. That means Formula Translator. You can see how we have separated them. It was developed for mathematicians, scientists, and engineers. It provides an easier way of writing scientific and engineering applications. Then we have Ada. This language was named after the first 3D programmer, Ada Lovelace. It is suitable for developing military, industrial, and real-time systems. Then we have very famous program called C. We hear everybody talking of C programming. It is mainly used for developing system software, such as operating system. Therefore, those are some of the examples of third generation languages. Then we can go to fourth generation languages or 4GLs. 4GLs make programming even easier than the 3GLs because they present the programmer with more programming tools such as command buttons, forms, text boxes, etc. The programmer simply selects graphical objects called controls on the screen and then uses them to create designs on a form by drag and drop. Therefore, you have been taught Microsoft Access Forms, and therefore you are conversant with what I'm saying. Then, what is the purpose of fourth generation languages? The 4GLs were designed to meet the following objectives. Number one, to speed up the application building process, to enable quick and easy amendments and alteration of programs, to reduce development and maintenance costs, to make languages user-friendly, to allow non-professional end users to develop their own solutions. Lastly, to generate bug-free codes from high-level expressions of requirements. Therefore, those are some of the purposes of or the reasons as to why the fourth generation was developed. Then, what are the examples of fourth generation languages? We have VB, a very famous language, Visual Basic. We have Defi Pascal, we have Visual Combo, and Access Basic, among others. Therefore, those are some of the examples of 4GLs. We have Visual Basic, don't forget that's Defi Pascal, Visual Combo, and Access Basic, among others. We have others. Then what are the advantages of fourth generation? Therefore, we have looked at the purpose, and therefore the purpose are still the advantages. Then we have the fifth generation languages or 5GS. Now, 5th generation languages are designed to make a computer solve a problem by portraying human-like intelligence called artificial intelligence. The language are able to make a computer solve a problem for the programmer. Hence, he or she does not spend a lot of time in coming up with a solution. The programmer only thinks about what problem needs to be solved and what conditions need to be met without worrying about how to implement an algorithm to solve the problem. And therefore, the 5th generation languages are mostly used in artificial intelligence fields. Examples, we have the Mercury, Occam, Lisp, and Prolong. Prolong is very famous. It's very famous in computer science when you are doing artificial intelligence. We use prolong. Therefore, those are some of the programs or examples of languages that belong to fifth. Therefore, prolong is actually means programming in logic, and Lisp stands for Lisp processing. Therefore, you can look at that. Then we have the most used part of programming languages. We call it object-oriented programming languages, or OOP. Many people will call them OOP, that is object-oriented programming. Therefore, it is a new approach to software development in which data and procedures that operate on data are combined into one object. OOPs use objects. And then what is an object? An object is a representation of a software entity, such as a user-defined window or a variable. Each object has specific data values that are unique. We call them state, which must do something. That is, they must have a behavior or a function. Therefore, several objects can be linked together to form a complete program. Programs send messages to an object to perform a procedure that is already embedded to it. This process of having data and functions that operate on the data within an object is called encapsulation. And therefore, when you talk about object-oriented programming, you can create one object that will be referenced several times by a class or by a process called inheritance. Therefore, examples of OOP, we have Simula, C++, we have Smalltalk, Java. You have heard of C++ and Java. Those ones are very common. Java is sometimes associated with development of websites and also development of mobile applications. Then Rust-3, we have the Rust category of high-level languages. We call it web scripting languages. Web scripting languages are mostly used to create web pages. Therefore, when you want to create websites, we use web scripting languages like HTML, XML. Those ones are very much used. And therefore, examples of this, we have JavaScript, VB-script, hypertext processor, or PHP. Yeah, those ones are some of the examples. Then, what are the factors to consider when choosing a programming language? When you want to choose a programming language like Java, like C++, like Visual Basic, like Pascal, what do you consider? Number one is availability of relevant translator. Never use a program that you don't have its translator. Whether the programmer is familiar with the language, that is very important. You cannot go to use Java and you don't know Java. Ease of running and use. Purpose of the program. That is very true. You must ask yourself, why am I running this language? Then execution time. We said different programs have different execution time. Then we have development time, popularity. That is true. Some people in the market will tell you use Java because it's popular, but not really because they know it, but because it is popular. Then documentation. Documentation means that is the guide on how to use it. Then maintenance, whether it is actually easy to maintain. And also availability of skilled programmers. If you are not the one using the program, make sure you know how many programmers outside there who can solve your problem using the language you want used. Then you can go to the next very interesting subtopic, program development. Just like any other thing on earth that develops, a program has a life cycle or stages that are used to accomplish a program. Therefore, we have 7 steps. Number one, we have the steps or stages used in program development. We call them program development cycle. And therefore, program development cycle consists of the following stages. Number one, we have problem recognition, that is identification of the problem. Number 2, we have problem definition. We have program design. Now see, the first two are problem, or the others are program. Program design, program coding, then you have program testing and debugging, then we have program implementation and maintenance, and lastly, we have program documentation. Now, when you talk about problem recognition, to recognize is to try and get the problem or the cause of problem. Therefore, problem recognition refers to the understanding and interpretation of a particular problem. The programmer must know what problem he or she is trying to solve. He or she must also understand clearly the nature of the problem and the function of the program. In order to understand the problem, look for the keywords such as compute, evaluate, compare, etc. Usually, a programmer identifies problems in the environment and tries to solve them by writing a computer program. There are 3 situations that cause the programmer to identify a problem that is worth solving. Therefore, this is very examinable. So you can be asked to give 3 situations that cause the programmer to identify a problem. Number 1 is problems or undesirable situations that prevent an individual organization from achieving its purpose. Therefore, you can opt to develop a problem to solve a program to solve a problem. Number 2 is an opportunity to improve the current program or even to come with a new program. Number 3 is a new directive given by the management requiring a change in the current system. Therefore, those are the 3 situations. Number 1 is to solve a problem when an opportunity arises or new directive from your seniors. Then we have problem definition. In problem definition, the programmer tries to define or determine the output expected, input needed, processing activities required or requirements, kind of files which may be needed. The programmer should write a narrative on what the program will do and how it is meant to achieve the intended purpose. Within this narrative, he or she is required to determine what data is to be input and what information is to be output. Therefore, when you are doing problem definition, make sure that you know the input needed, the output expected, what processing activities will be used or requirements, and then what kind of files will be needed. For example, in calculating the area of a circle, the parameters needed to determine the area of a circle are input. Now look at how this has been broken down. Input, we have pi, we have the radius. Then processing, we have the formula, that is pi times radius. That is what the processing will do. Then what will be the output? Area. Area will be the output. Therefore, look at how that one has been used to show you how problem definition is done. We have agreed it is done by identifying the input, the processing activities, and also the output, without forgetting the files that will be used. Then we can go to the second phase. We have program design. Program design is the actual development of the program's process or problem-solving logic called algorithm. Therefore, an algorithm refers to series of steps followed when solving a certain problem. And therefore, it's also very important to know that algorithms, that is the series of steps used to solve a problem, are of different kinds. We shall look at that. It involves identifying the processing tasks required to be carried out in order to solve the problem. The design stage enables the programmer to come up with a model of expected program or a general framework, an outline of how to solve the problem. and where possible, break it into a sequence of small and simple steps. The models show the flow of events throughout the entire program. Therefore, basically, when we talk about program design, we draw flowcharts, we write pseudocodes, we draw entity relationship diagrams, etc. Then it is also very important to note that we have modular programming, just as a terminology there. Many programs are non-monolithic. That is, they are not usually made up of one large block of code. Therefore, a program that is made up of a large code without subdivisions is called non-monolithic. The opposite of that one is module. Instead, they are made up of several units called modules that work together to form the whole program, with each module performing a specific task. This approach makes a program flexible, easy to read, and carry out error correction. Therefore, modular programming is coming up of a program that has been divided into small parts called modules. Then you can go to the next stage. We have program coding. Program coding is the actual process of converting the design module into an equivalent program. Coding requires the programmer to convert the design specifications or algorithm into actual computer instructions using a particular programming language. For example, the programmer may require to write the program code either in Pascal, C++, Visual Basic, or Java, and develop suitable identifiers, variable names, and data types. However, remember that at this stage, the coding is still a pencil and paper exercise. The end result of this stage is a source program that can be translated into machine readable form for the computer to execute and solve the target problem. Now, what are the rules of coding? Rules followed in coding a program. Number one, use the standard identifiers or reserved words. Make the program more readable by use of meaningful identifiers. Don't use similar variables. Keep spelling as normal as possible. Use comments to explain variables and procedures. Avoid tricks. That is, write the program using straightforward codes that people can readily understand. Modularize your program. That is, break down your program into smaller sub-programs. Then the next stage is called testing. Once you now design and code your program, you need to test. Testing is the process of running the program software to detect or find any errors. We have agreed we also call errors bugs. Therefore, testing is the process of running computer software to detect any errors in the program that might have been gone unnoticed. During program testing, the following details should be checked. Number one, you have to check the reports generated by the system, the files maintained in connection to the system information requirements, the input to the system, the processing tasks, and the control incorporated within the system. The testing process is a continuous process. Don't forget that. You keep on testing. Then there are some errors that must be there so that testing should actually be carried. Therefore, the purpose of testing is to identify the errors. Therefore, what are the types of program errors that are encountered? Therefore, we have several. We have syntax errors. We have runtime or execution errors. We have logic or arithmetic errors. We have semantic errors and lexicon errors. But basically, the first three are very common: syntax errors, runtime errors, and logical errors. What are syntax errors? We said syntax is the language, and therefore syntax errors are programming errors or mistakes that occur if the grammatical rules of a particular language are not used correctly. For example, punctuation marks, improper naming of variables, wrong spelling of reserved words. Therefore, syntax error is just an error that occurs when you violate the grammatical rules of a particular language. Then you have the logical or arithmetic errors. These are errors that occur these are errors in the program logic. Logical errors relate to the logic processing followed in the program to get the desired results. For example, they may occur as a result of misuse of logic operators. Therefore, they are just errors that make result to wrong results. The program runs but give wrong results. Then we have runtime errors. These are errors that occur during program execution. These errors are not detected by the translator, but are detected by the computer during execution. Sometimes execution errors may lead to premature end of the program. Therefore, be very keen on those ones. Then you can look at debugging. We have said an error is called a bug, and therefore debugging is the removal of those bugs or errors. The term bug is used to refer to an error in a computer program, and therefore debugging is the process of detecting, locating, and correcting by removing or eliminating all the errors. Therefore, types of testing. For you to identify the errors, you must test. And therefore, let's look at the methods of error detection or types of testing. Therefore, let's use the term methods of error detection. We have dry running or desk checking. We have translator system checking. We have functional testing, use of test data, use of debugging utilities, diagnostic procedures, system test with actual data, but we shall basically look at dry running, use of test data, and use of debugging utilities. Therefore, dry running. Dry running is a method of checking a program for errors by making corrections on a paper before entering it into the computer editor window. Therefore, when you're writing the codes on your paper, that's where you go through them with a different pen and identify the errors. When you are doing that, then you are doing desk checking or you are doing dry running. Number two, you can use test data. The accuracy of a program can be tested by inputting a set of values called test data. You actually give wrong information or you give wrong data to see whether the computer will know or it will identify the problems. There are two types of test data. We have live data and dummy data. Real data or live data, this is test data obtained from the real problem. Then we have assumed data, that is the dummy data, that is assumed. Therefore, you can use assumed data or you can give data that has been provided for you. Number three, you can test your program by use of debugging utilities. That means the machine itself will do this. After the program has been entered into the program editor, debugging utilities which are built-in computer can be run during translation to detect any syntax error in the program. Therefore, there are three main ways of error detection: dry running, use of test data, and use of debugging utilities. Then we can look at the second last part of the stages. We have implementation and maintenance. We start with the program implementation. Implementation refers to the actual delivery, installation, and putting of the new program into use. Therefore, this is whereby you copy your program, for example, in a flash disk or in a DVD, and take it to the owner and then install for him or her to use. That is implementation. Therefore, the program is put into use after it is fully tested, well documented, and after training the staff how they will actually run the program. Then we have structured walkthrough. It is an organized style of evaluating or reviewing a program by a team of other programmers, which then reports to the programming team. Therefore, you can be asked what is structured walkthrough. It is giving other programmers your copy to go through it and identify whether it meets the requirements of the organization. Then we have review and maintenance. Once the program becomes operational, it should be maintained throughout its life. That is, new routines should be added, obsolete routines removed, and the existing routines adjusted so that the program may adapt to enhance functional environment. The main objective of maintenance is to keep the system functioning at an acceptable level. Program maintenance mainly involves correcting errors, that is, changing procedures, hardware and software maintenance, changing parameters and algorithms used to develop the original program, and lastly, making any adjustments as new technology comes, that is making it, that is to update the system. Then lastly, the lastmost stage of program development is program documentation. After writing, testing, and debugging a program, it must be documented. In other words, the programmer should describe all what he or she was doing during the program development stages. Program documentation is the writing of supportive materials explaining how the program can be used by users, installed by operators, or modified by other programmers. Let me repeat. Program documentation is the writing of supportive materials explaining how the program can be used by users, installed by operators, or modified by other programmers. That is actually in the future. We have two types of documentation. We have internal documentation and external documentation. When you're writing a program, you can write few sentences that are not executable for explanation of what you are doing. We call them comments. And therefore, when you talk about internal documentation, it is the writing of non-executable lines. We call them comments in the source program that help other programmers to understand the code you had written. Then we have the materials or booklets you call manuals. We call them external documentation. Refers to the reference materials such as users' manuals or booklets. And therefore, let's look at the types of program documentation. We have looked at the two classification, that is internal and external. Let's now look at the types. We have user-oriented documentation. This enables the user to learn how to use the program as quickly as possible and with little help from the program developer. Therefore, you have user-oriented. Now we go to operator-oriented documentation. This is meant for computer operators, such as the technical staff or the technician. They have their own manual, operator-oriented. The users have theirs, called user-oriented. Then the programmer will come to improve the program. They have their manual called programmer-oriented documentation. This is a detailed documentation written for skilled programmers. It provides the necessary technical information to help in future modification of the program. That is very important. Then some documents used in program documentation. You can have the user guide or manual. You can have the reference guide, quick reference guide, and technical manuals. These are some of the documents used in program documentation. Then we can go to development of algorithms. First of all, we need to know what is an algorithm. We said an algorithm refers to set of a series of steps followed when solving a certain problem, but still we have more definitions. An algorithm is a limited number of logical steps that a program follows in order to solve a problem. A step-by-step instructions which, when followed, will produce a solution to a given problem. Therefore, those are some of the definitions that a student may give, or you can give on what is an algorithm. Then we have program design tools. algorithms can be illustrated using the following tools. Therefore, you need to know the program design tools. We have pseudocodes, we have flowcharts, we have decision tables, you also have decision trees. And also you can add, we have ERD. That is, ERD means entity relationship diagrams. You also have those ones. Therefore, for now, let's basically look at pseudocodes, flowcharts, decision tables, and decision trees. Now let's start with the pseudocode. What is a pseudocode? A pseudocode is a method of documenting a program logic in which English-like statements are used to describe the processing steps. These are structured English-like phrases that indicate the program steps to be followed to solve a given problem. The term code usually refers to a computer program. This implies that some of the words used in a pseudocode may be drawn from a certain programming language and then mixed with English to form structured statements that are easily understood by non-programmers and also make a lot of sense to programmers. However, pseudocodes are not executable by a computer. Therefore, you need to know that pseudocodes are written on your book, on your exercise book, or on a paper, trying to indicate how the program runs. Therefore, we have guidelines for designing a good pseudocode. Number one, the statement must be short, clear, and readable. Number two, the statement must not have more than one meaning. They should be non-ambiguous. The pseudocode lines should be clearly outlined and indented. A pseudocode must have a beginning and an end, that is start and stop. Then the input, output, and processing statements should be clearly stated using keywords such as print, read, input. Therefore, let's look at our first example. Write a pseudocode that can be used to prompt the user to enter two numbers, calculate the sum and average of the two numbers, and then display the output on the screen. Therefore, we have said a pseudocode must have start and stop. Therefore, you can see it has start and stop. We have said it should be indented. Look at how the words have been pushed away from the margin. That is called indentation. Then the use of print, input, those ones are the keywords, the reserved words that we have agreed. Therefore, look at what we are doing. Print, enter two numbers. Then input the two numbers x and y. Sum, that is add them up, x plus y. Average, that is get the average, sum divided by 2. Then print sum, print average. Look at those statements. Therefore, those are the how we write a pseudocode. Then you can look at example number 2. Write a structured algorithm that would prompt the user to enter length and width of a rectangle, calculate the area and perimeter, then display the result. Look at the solution. Draw the rectangle of length L and width W. Therefore, write down the pseudocode. Start, print, enter length and width. Then read length and width. Then calculate the area. Area equals to length times width. Then calculate the perimeter. Perimeter equals to 2L plus W. That is width plus length. Then print area, print perimeter, stop, start. Write that, stop. Therefore, that's how we write a pseudocode. You can practice on that. Then you can also look at this. Write a pseudocode that can be used to calculate the diameter, circumference, and area of a circle, and then display the output on the screen. Therefore, you can see how we have started. Start, set pi to 3.14. Prompt the user for radius. Store the radius. Set the diameter to 2 times radius. Set the circumference to pi times 2 times radius. That way, then print diameter, print circumference, print area, stop. Therefore, you can see now how we write a pseudocode. This cannot be executed by a computer, but you can write it in a computer program after you have written it on a paper. Then you can also look at this example. Write a pseudocode for a program that can be used to classify people according to age. If a person is more than 20 years, output adult, else young person. Therefore, see how the program, the pseudocode has been written. Start, print, enter the age, input age. If age is greater than 20, then print adult, else print young person, stop. Therefore, you have seen how pseudocodes are done. Therefore, now let's head to program flowcharts and later look at the. Hi guys, today I will take you through program flowcharts, that is on how to do program flowcharts. Therefore, to start with, we shall ask ourselves, what is a flowchart? A flowchart is a diagrammatic representation of a program logic or a program algorithm. A flowchart is constructed using a set of special shapes or symbols that have specified meaning. Symbols are used to represent operations or data flow on a flowchart. Each symbol contains information or short text that describes what must be done at that point. The symbols are joined by arrows to obtain a complete flowchart. The arrows show the order in which the instruction must be executed. Symbols used in program flowcharts. Therefore, we shall now at this point look at the symbols used in program flowcharts. Below is a standard set of symbols used to draw program flowcharts, set by the American National Standard Institute. And therefore, for now, we shall go through the symbols used in flowchart one by one. Then we shall later draw a flowchart showing whether we have actually understood on the shapes. Therefore, the first shape that you need to know when drawing a flowchart is the terminal symbol, that is an oval, or we call it an ellipse. It is used to indicate the point at which a flowchart, a process, or an algorithm begins and ends. Therefore, this symbol here you are seeing is used to show start and stop, or begin and end. All flowcharts must have a start and a stop symbol. That one, that's the oval. The start stroke begin symbol is the first symbol of a flowchart and indicates the point at which the analysis of the flowchart should begin. The stop stroke end symbol above is the last symbol of a flowchart and indicates the end of the flowchart. The words begin or end, or start and stop, should be inserted in this symbol. Don't forget, this symbol must either indicate start or stop. That is, you must type the word start or stop. That is, start for the beginning and stop for the end. Then we go to the next symbol. The next symbol is a parallelogram. We call it input or output symbol. It is used to identify or specify an input operation or output operation. For example, if I want to read the name of an employee, that is input. Therefore, you can see the way I have done input operation. You use it just the way it is. You draw, but when you are showing an input, you use keywords like read, input, or print. Therefore, note the words mostly associated with input or output, we have read or print. Therefore, you can use the word read for input and the word print for output. Read describes the entry of computer data, while print relates the printed output of information. Therefore, you can see how I have explained how to use the symbol. Therefore, the symbol, when drawing a flowchart to show you are getting an input or you are showing an output, you use a parallelogram. Therefore, you can see read employee name. On the other hand, we are now outputting, output operation, print employee name. Then the next symbol is called process symbol. It is rectangle. in shape, therefore it is rectangle. A process symbol is used to indicate that a processing or data transformation is taking place. The information placed within the process symbol may be an algebraic formula or a sentence to describe processing. For example, if you look at example number 1, sum equals to A plus B. I am adding two numbers. On the other hand, commission is computed at 20% of total sales. Therefore, number 1, processing is defined as a formula. Number 2, processing is defined as a sentence. Therefore, when you use the rectangle or process symbol, you are showing that you are processing something. You are transforming data from one state to the other. Therefore, if you see a calculation and you want to show somebody in a flowchart that you are doing a calculation, like you are adding up, you are dividing, you are multiplying, you draw a rectangle. Later on, we shall see how it is used. Then the next symbol, and very important, is called decision symbol or robbers. We use the robbers. Those two arrows show a direction of a yes, the other one shows a direction of a no. Therefore, decision symbol, the one you can see there, it is used to indicate, stroke specify a condition or to show the decision to be made. There are two main components of a decision symbol. Number 1, a question asked within the decision symbol that indicates the comparison or logic operation. Number 2, the results of comparison, which are given in terms of yes or no. When we talk about yes or no, in one word, in programming we say Boolean. That word there, Boolean, is read as Boolean. The arrows labeled yes or no read to the required action corresponding to the answer to the question. Therefore, note that, very important, though I will be showing you how they are used practically. Therefore, that is the next symbol that is from the process is the decision symbol. We shall see how it is used. Therefore, don't forget, it is used to indicate or specify a condition or to show the decision to be made. And then there are two main components of it. Number 1 is the question. Number 2 is the flow of yes or no. Then we have flow chart lines or flow lines or arrows. Therefore, they can be either top, bottom, they can be right, left, like I have shown you. Flow lines with arrowheads are used to indicate the direction of processing of the program logic. They show the order in which the instructions are to be executed. The normal flow of a flowchart is from top to bottom and left to right. Note, flow lines should never cross each other. Therefore, flow lines should not actually flow to each other, that is cross to each other. Then from there, we have the connector. Now the connector, on the other hand, the connector symbol. Sometimes a flow chart becomes too long to fit in a single page, such that the flow lines start crisscrossing at many places, causing confusion and also making the flowchart difficult to understand. Therefore, this sign here is called a connector. On the other side, we have said that they should not cross to each other, and therefore the solution for that is to use a connector. Sometimes a flowchart becomes too long to fit in a single page, such that the flow lines start crisscrossing at many places, causing confusion and also making the flowchart difficult to understand. The connector symbol is used as a connecting point for arrows confusing from different directions. A connector symbol is represented by a circle. Therefore, this circle is the connector symbol, and a letter or digit in place within the circle to indicate the link. Note, connectors do not represent any operation. They are used to connect two parts of a flowchart, indicating that flow of data is broken. Therefore, we shall also be looking at that. Then from there, we can go to general guidelines for drawing a program flowchart. Then I will take you now to the practical session where we shall draw several program flowcharts. A flowchart should have only one entry stroke starting point and one exit. Therefore, you can never draw a flowchart, a program flowchart with two starts or more than one end. The flowchart should be clear, neat, and easy to follow. The flowchart should be clear, neat, and easy to follow. Mark that. Use the correct symbol at each stage in the flowchart. Therefore, avoid confusing the symbols. And to be clear on that, make sure you understand each and every symbol. The flowchart should not be open to more than one interpretation. That is, should be unambiguous. Avoid overlapping the lines used to show the flow of logic, as this can create confusion in the flowchart. Make comparison instructions simple, that is capable of yes or no answers. The logical flow should be clearly shown using arrows. Note, a flowchart should flow from top to bottom of a page and from left to the right, depending on the conditions. Where necessary, use connectors to reduce the number of flow lines. Connectors are helpful when a flowchart is several pages long and where several loops are needed in the logic of the flowchart. Check to ensure that the flowchart is logically correct and complete. Therefore, make sure you follow those guidelines when drawing a program flowchart. We shall do examples and therefore you will see how that one is met. Then from this point, we can go to questions. That is, we can draw several flowcharts. Then after drawing several flowcharts, you'll be in a position now to understand what you are actually doing. Therefore, question number 1. Draw a flowchart for a program that can be used to prompt the user to enter two numbers and find the sum and average of the two numbers and then display the output on the screen. Now mark, we have learned about the start of a flowchart and end of a flowchart. We have also learned how to get input and how to get output. We have also learned how to process. Therefore, in the first question, we shall not use connector. We shall not also use decision. In the next question, design a flowchart for a program that can be used to classify people according to age. If a person is more than 18 years, output is adult. Otherwise, the output is young person. Therefore, in the next question, we shall also be looking on decision. We shall now include a decision. Then we shall go ahead and answer question number 3. In a class, awards are given to position 1, 2, and 3 as follows. Position 1 is awarded Kenya shillings 2,000. Position 2, Kenya shillings 1,500. Position 3, Kenya shillings 1K. Draw a flowchart to show how the above task can be represented diagrammatically. Now, the purpose of this question is to actually have use of all the symbols of a program flowchart. Therefore, let's start by drawing a flowchart. That is question number 1. We shall draw a flowchart for a program that can be used to prompt the user to enter two numbers, find the sum, average of the two numbers, and then display the output on the screen. Therefore, let's launch Microsoft Word, and then we shall do that one practically. Before we launch our Microsoft Word, then I can use it to, we can use this one to do our practical session. And therefore, now what you need to do is we are drawing a flowchart to get two numbers. Therefore, we have run of these symbols. Therefore, we have said this symbol, that is the oval. This one is used to show start, and therefore you just draw it, then you write inside it start. We are starting our program. Then draw a flowchart for a program that can be used to prompt the user to enter two numbers. Therefore, the next thing is to draw input. We shall draw input, and therefore we shall draw input for two numbers. Input, we have said we use the parallelogram to enter input, and therefore this is the start, then this is input. What are we inputting? Two numbers. Therefore, let's input two numbers. Therefore, we use words like input, we use words like read. Yeah, those are the best one. Therefore, we shall write input two numbers, Q and P. Therefore, our two numbers are Q and P. Those are the two numbers that we shall be capturing. Then we go to the next question. Enter two numbers. I have shown you how to get that. Then find the sum and average. Therefore, what are we doing? We are processing. Therefore, we go to this point and then we draw a process. A process is a rectangle. Therefore, we process. What are we processing? We are processing the sum. Then we draw again another one for processing the average. Therefore, first of all, I have not connected, but you can see what we are doing. We are now practicing on what we have run. We have input. We have started our program. We have used the parallelogram to get input of two numbers. Then now we process the sum. Therefore, you just come to this point and then write sum equals to Q plus P. Is it? I'm sure you have said yes. Therefore, then we shall now get the average. We are following the question. We find the sum and average. Therefore, we get now the average. Now the average, we write average. Now average equals to Q plus P divided by, we use the forward slash, divided by 2, is it? I'm sure you have also said yes in that. Then from there, then display output. Therefore, we go and draw what? Output. Therefore, add output the sum and average. Therefore, we shall now draw the output. The output, we have said the output and the input we use parallelogram. Therefore, this one will now output. You can use the word print or output. Therefore, output, we are outputting average, comma, sum. There is no need of writing two outputs. Just write one to make things easy. We are here to make life simple. Therefore, you also make your life simple. And therefore, we are inputting average, comma, sum. That way. Therefore, that way you will be showing the examiner that you are outputting both of them. Even now here, you can remove one and put these formulas in the same. Like for example, I would have done this. I would have brought this formula here to show that they are being processed this way. Even that one is very correct. That one, you can do that. That one is also very correct because since they are being processed, you can reduce the number of shapes by combining them that way. Therefore, look at how our program is. Therefore, because our program has reached the end here, that then display the output on the screen. We have displayed. We display using a parallelogram. Therefore, we can now end our program. And we have agreed we end our program by the oval or the ellipse. Therefore, stop. You can use start and stop, and you can use begin or end. Then from here, we have run off an arrow. An arrow shows direction, and therefore you must draw an arrow showing that your program is running from top to bottom. You see? Therefore, that's what I am actually now doing, that I have now drawn my flowchart. Therefore, if want to make sure that it is readable. Therefore, look at our flowchart now. Look at our flowchart. Look at our flowchart. Our flowchart is complete. We have started. We have input two numbers using the parallelogram. We have also processed the sum and the average using the rectangle. That is the process. Then we have output, average, and sum using the parallelogram again. Then we have stopped. Therefore, we have now answered our question. We have answered our question that is, draw a flowchart for a program that can be used to draw a flowchart for a program that can be used to prompt the user to enter two numbers, find the sum and average of the two numbers, and then display the output on the screen. Therefore, I am sure you have understood how to use the symbols. Therefore, let's understand more. Go to question number 2. Design a flowchart for a program that can be used to classify people according to age. Therefore, we shall input what? Age. If a person is more than 18, therefore we shall use a decision, then output, and then end our program. Therefore, let's go and do that. Therefore, we start another Microsoft Word. Then we can draw together. Therefore, we are now classifying people according to age. Therefore, you come to this point, we will draw the start. A program must have one start. Therefore, that's our start. You write start or begin, but I like using start. Therefore, we write start. Then, what are we getting? We are asking for age. What is age? Input. Therefore, we input. What are we inputting? We are inputting age. And therefore, here we shall ask for age. Therefore, enter. You can use the word enter or input. Input. Using input. Input age. Therefore, what are we getting from the user? Age. We are asking for age. Therefore, input age. We have started our program. We have now asked for age. Then, after asking for age, what do? We make a decision. Is age greater than 18? Remember what we have said? What we have said in decision. What have we said in decision? We have said that there are two main components of a decision. A question asked. Therefore, I am asking, enter the age. Yes. Is age greater or equal to 18? That is the question. Then what is the component number 2? The results following yes or no. Very good. Therefore, let's carry on. Now we have drawn the age. Therefore, let's go and ask the question. We use the raw bars. This one. This is the decision. Therefore, we write our question. Is age greater or equal to 18? Then you put a question mark. That's what we have agreed. We must have a question. Therefore, look at what I'm doing. I'm asking the question. Is age greater or equal to 18? That way. I want 8 feet. Good, that way. Therefore, look at what we are doing. We have started, we are inputting age, start, input age. Now we are in question. We have said we have two parameters in decision. Question and the direction of yes or no. Therefore, at this point, we shall now draw our direction. That is yes and no. Therefore, I'll show you how to go about it. Therefore, you can draw an arrow going to one direction, the way we did in our question, in our lesson. Therefore, you can see. Therefore, here we can write no. Is age greater or equal to 19? No. Then what happens? Then down here, yes. Then what happens? Therefore, let's do that. Therefore, I shall just go to this. You take a text box. Therefore, this is no. And if it's no, we shall see what happens. Therefore, this is our no. Then, on the other hand, we have our yes on the bottom side. Therefore, we have yes. Then if it is yes, what happens? Now see what happens. Therefore, let's carry on. Now, let's first of all follow no. If age, according to the question, if we go to the question, if somebody has attained 18, we shall output adult, else we shall output young person. Therefore, we go to no, we go to line of no, then what happens? We draw an output. Therefore, we can draw an output here. That is for no. Therefore, you can show this arrow is going down at this point. For this one, after reaching here, it will go down. It is important if you can join them. Therefore, we just make this one a bit longer. Then we show that we are actually now going to that. Therefore, we have been told if somebody has not attained 18 years, then we shall give what? Young person. Therefore, our output here is young person, and therefore you right click here. Okay, for you to be writing in your pen, therefore young, that is output young person. That is if no, if age is not greater or equal to that one, we are outputting young person. Output young person. Then what if it is an yes? If it is an yes, then you also draw an output here. If it is an yes, then we have been told our decision is output adult. That way, therefore we shall just output adult as we have been instructed. That way. Then our program ends. And if our program ends, then we go to the shape that I have just taken you through, this shape here, stop. And therefore our program goes and stops. That is stop. Should not be stops, should be stop. Therefore stop. Then you have to indicate with an arrow that our program is actually stopping. Therefore you can just do that. Remember, you don't crisscross them. Therefore, we can go to this point. Then we can now introduce a connector here, just for understanding purposes. Therefore, connector is just a small circle like that. Then we shall now show that our program here, this one, it's there. This one can just go down. Then from there, they join each other and then goes and stop. Therefore, you have now seen that. Then from here, we indicate the direction of our flowchart. Our flowchart is top bottom. Therefore, it is heading this way. There we are. Therefore, we have now drawn our program. We have introduced connector. We have also introduced what? We have also introduced the decision, this one. Therefore, I have introduced the decision. I have also introduced the connector, how to use the connector. Therefore, those are the two things that I wanted you to see. And therefore, our flowchart looks like this. Therefore, you can see how it looks like. And we have started. Then we have input age. Then we have made a decision. Is age greater or equal to 18? No. Then we have output. Yes. Then we have output. Then the program connects each other and stops. Therefore, so far, we are still going somewhere. You can see we are going somewhere. We are actually now understanding some of the tools, symbols that we have so far. And therefore, I have shown you how to use a connector. I have also shown you how to use a decision. We have also learned how to use the flow lines. We have also learned how to use the process symbol. We have also learned how to use parallelogram or input-output symbol. We have also learned how to use the terminal symbol for start and stop. Therefore, let's carry on with more and more examples. I want you to understand. I want you to be very well equipped. Therefore, let's go and tackle this question. In a class, hours are given to position 1, position 2, and position 3 as follows. Position 1, Kenya shillings 2,000. Position 2, 1,500. And position 3, Kenya shillings 100. Therefore, at this point, we shall be introducing decisions, but actually it is actually use of the decision and processing, but we shall use everything. Actually, we shall use all symbols again. This one will also make us understand more. Therefore, let's do it practically again, just like we have done. Therefore, what is the first question? The first thing is to draw start. Therefore, we go and draw our start. Now, once we draw our start that way, we go again and ask for the position. What is position? We are asking for the position. Therefore, we input, and therefore we shall come here and input the position. Which position is the student? Therefore, our key point here is the position. We are getting the position. Then, after getting the position, what do we need to do? Is to have decisions. Is the student position, that is the student position 1? No. Is the student position 2? If the answer is no, is this then the student position 3? Therefore, you shall have 3 decisions. Look at what I'm doing for you to understand these things. Therefore, we shall have 3 decisions. Decision number 1, asking, is the student position 1? Therefore, we shall just come here and ask our question. Remember the rules of decision. Is position equal to 1? Then a question mark. If no, is position equal to 1? No. If it's no, then the program will ask itself, is position equal to 2? If no, then it will ask itself, is position equal to 3? Else, then there is no position. Therefore, those are the 3 positions. Is position equals to 1? Is position equals to 2? Is position equal to 3? Then, what happens? We shall process the position. We shall process the money, the award. Therefore, down here, we shall use position. And therefore, we shall have the 3 positions. I'm copy pasting for easy and quick response. Therefore, at this point, what shall we process? Therefore, we shall just say that award equals to 2,000 shillings if it is position 1. Then here, award equals to 1,500 if it is position 2. Then here, then at this point, award equals to 1K, that way. Therefore, that's what we have done so far. Therefore, that's what we have done. Then that's what we have done. Now look at what I'm doing. Therefore, I'm actually doing the way it's supposed to be. That is according to our question. I want you to understand more. I want you to grasp every concept on what we have actually learned so far as we use the symbols. Therefore, after position is given 2,000, position 2 is given 1,500. This is position 3, sorry. I edit this position 3. If position 3 is given 1K, what then happens? An output is given. An output is given here. An output will be given, and therefore the output will be display award. Therefore here, output award. Therefore, award will be outputted by the system. The system will now output the award given to every student. Then what will happen after this? The program will stop, and therefore we shall have answered our question to the fullest. Therefore we go to that point, then we go to add, then stop. Therefore this one will be stop. That way. Then there we are. Now let's introduce the arrows and other things that are supposed to be done. Therefore look at how I connect things. Therefore I go to insert, then you draw the arrow. Therefore we are going this way, top down. I take another arrow. Now this point is a bit complex because it will just have one entry. Remember we have talked of having, therefore our program will be like this. For this this point here, it's not a must use an arrow. Look at how I go about it. You can use the straight line. Just draw that way, then take another straight line to this point. And this one should join that one. Good, there we are. Therefore, look at how the direction is. The direction you have taken, it should actually go that way. Then from here, after the input position is given, the computer will now start making decision. Therefore we go and show the direction. Therefore if somebody is not position 1, computer will go and check, is he or she in position 2, is he or she position 3. Therefore look at the direction I'm taking. Our system will be going that way. Then it will also be given giving out some other arrows here. That is, it should, if position is 1, then it will process. Therefore also this one will go down here. It will just go this way. Look at what we are doing. Therefore it should also go that way. Then here, since these are many, we shall use a connector, and therefore I will come down here and draw a connector that way. Then I will draw a straight line from here towards this. That is, this one should be an arrowhead to show direction. Therefore I will draw an arrow showing that this one is going this way. Then I use a straight line here to show that this is actually going to that. Then here, since this is direct, this one will go direct to the connector. Then this one also will go to that point that way. Then I'll use a straight line here to show that this is going to this point. Now see what I am doing. I am introducing you to all the signs we have run and how we use them. Then after here we shall have a one arrow now going downwards that way. Now look at what I'm doing. I'm using all the symbols that we have run and how we use them, and I'm sure at the end of this lesson you'll be in a position to draw flowchart wholeheartedly with a lot of joy, since the teacher has taken you through how it goes. Therefore look at how we have drawn our flowchart. We have started, we have input position. Now after inputting position there, then the computer will ask, is position 1? Yes, it awards 2000, then 2000 is printed here. If no, therefore we can still finish by putting no here. We can use letter N for no that way. Then we can just copy, paste. Instead of rewriting, we are computer guys, therefore we don't need to get so much tired by typing some stuff. Therefore this side here, this is yes, you use Y. We have talked of Boolean, therefore this is yes. Can just copy paste again. If I can take one Y there, I can paste again and take one Y there. We are computer guys, we are here to make life simple. Therefore now see what is happening. Position 1, no, position 3, Computer comes here. Position 3 is not position 1, therefore it is no. Position 3 is not position 2, therefore it is no. It goes here and awards 1000. Then the 1000 is printed here. Else, if somebody is not among those positions, it will just come and stop. Therefore, you can do this. Look at what I'll do. Yeah, that is to show that we are actually you bring it up to this end, because if somebody enters position 6, the program should only come at 8, because position 6 is nowhere, it is not being awarded. Therefore, but to understand more and more on this, I shall have more practice. Therefore, look at what I'm doing. That our program is now complete. Start, we have started, input position, then we have used all the tools that I have taken you through. We have used decision and or others, including the connector. Now, assume a situation whereby your flowchart has reached an end here and you did not include this. It did not include that. For example, now assume we introduce exit. We introduce a small decision here, a small decision exit, that make us not to end our program. Exit that makes our program not to end at this point. For example, now let me take you through the use of the advanced use of connector. Now assume our program exited there. That means it should go to the next page. That is, our program should go to the next page. If I want our program to actually that will be very good. I want us to have another page here, and therefore our program, because of some reasons, reached an end here. Let's make this smaller. Also, this one goes a bit up. Now, program did not fit in this page. Therefore, you can introduce a connector here, then give it a letter. Our connector here is given letter. In the letter, you can give it A that way. Now, this connector of ours that we have given A, to continue with our program, we shall draw another connector in the next page. In the next page here, insert shape, then we can draw another connector here. Then we shall show whoever is reading our program that A is equal to A, that we are continuing. Look at what I'm doing. This flowchart of ours, okay, there is some mix up. Let me first of all fix that. We can just fix that in a moment. Now I want to take this one to the other page. This one should be here, so that you can understand. Very good. I want you to understand very well. Now look at our program. Our program did not end here, and therefore, because it did not end, we can cut this. We take it here. I want you to have the best of knowledge on flowchart, and you'll never fail this class again once you use this. Now look at what I'm explaining. Now our flowchart is has broken to the next page, and therefore I want to show the person it did not end here, and therefore I continue to the next page. Therefore this A is equal to this A. Therefore I only now continue. I'll just continue and show that the remaining part of the flowchart is in the next page. Therefore stop. Stop. Now see what I have done. That's how we explained that a connector can be used to join two pages. Therefore, my flowchart came all over, but since it could not fit in page 1, I continued it to page 2. That's how you can use a connector. This one was supposed to be there. That's how you can use now a connector in another way. Therefore, one way of using a connector is the way I have used it here. Second one is how I have used it on this point. Then we can proceed and go to the next question. Draw a flowchart that can be used in the following scenario. Ask the user to enter 3 numbers. Divide the first 2 numbers by each other. If the value of the first number is 0, the program should display error message div 0. Otherwise, it will display the answer for the problem. Therefore, let's look at that one. Let's see how such question can be really tackled, and that one will actually be very good. Therefore, we go to our Microsoft Word. We start our new page, then go to our question. We are asking for entry of how many? 3 numbers. Therefore, we just go to this point, start our program, shape, start. Then that is the input. We start just like we have done. Remember, we are running the program flowchart, how to draw them. Then we go to start. Then what are we supposed to do next? We are supposed to capture. We are supposed to enter 3 numbers, and therefore we shall draw that one and then write inside it input 3 numbers. Therefore, we are inputting A, B, C. That is the next thing we are doing. Therefore, we are inputting 3 numbers, and those are our 3 numbers that we are capturing. Therefore, we are capturing our 3 numbers, A, B, C. Then what happens after we capture? We shall check, divide the first 2 numbers by each other. If the value of the first number is 0, therefore the computer will first of all check whether the first value is 0. If it is not 0, it goes and divides. If it's 0, then an error message comes. Therefore, we just go to decision. We shall draw our decision here, just like we have done in the one. Therefore, here we have said a decision usually have 2 parameters, question and boolean, yes or no. Therefore, it will check is, now we are taking the first 2 number A and B. We are not using C. Therefore, it will check is A equal to 0. That is the condition. That is the condition that that will be checked. Therefore, if yes, if no, don't forget that. That is the next condition of a decision. Therefore, you just go line off. Is yes, is no, is yes. It can go anyway. No can come here, yes can come. There is no professional way of saying that this must. There is no must there. Therefore, we can just go with no there. This is our no. Therefore, what if it's no? Then on the other hand, you can just copy this. We are programmers. We don't need to make life complicated. Just make life simple. Therefore, we have whatever we have agreed, that a decision must have yes or no and a question. Is A equal to 0? We have been told what? If it is 0, then it will give a message. It will give a message div 0. Otherwise, if it is yes, if it is no, it will go ahead and calculate the sum. And therefore, for that matter, we can just interchange this. Yes, then this becomes no, just for space purposes. Therefore, if it is 0, then it will display an error message. Therefore, you can write our error message here. Therefore, it will just give an error message. If it is divisible by 0, it will give an error message div 0. That is, it will output. Use the keyword out. It will output div 0. Therefore, this is whatever we shall be given. Div 0. That is the output. Output div 0. That is if it is yes. And therefore, you can bring this here, then show the direction of the arrow. That this one is actually, it is heading this way. Therefore, for that matter, you can just go to shapes, then draw that, then terminate with an arrow. That way. That format, that div 0. But what if it is no? It goes ahead and divides A and B, and therefore we shall process. If it's no, then what happens? If it's no, it will divide then it will divide. Therefore, it will give the quotient. Quotient is the answer you get when you divide two numbers. Therefore, it will give the quotient of A divided by B. In computer, we use /. This is to show division. Therefore, this is what will happen. Quotient, I have said, it is the answer you get when you divide two numbers. Or rather, it's not a must you would get this. You would have done that. Even that one is correct. It is actually 100% correct, even more than the other one, because the other one I have adding things that I was not given. Therefore, you can just type that, but you know a formula must start with an equal sign. Therefore, you can type equals A or B. Therefore, if A is 0, it ends this way. If it is not 0, then it divides A and B. Then what next? The next thing is an output. That is the answer here. And therefore, that it is important we give the word quotient for the purpose of, you can use Q. Q equals to that, or answer. You can use the word answer to make sure, so that we can get something to write here. And therefore here, what shall we give? Output answer. Output answer. That way. Therefore, that's what happens. Output answer. Then after outputting the answer, the program stops. Our program stops. That way. Therefore, we can come here and write stop. Right click. We write stop. That way. Then now we can just give our arrows for direction purposes. We can show our arrows, insert shape, then we can show our direction. If we just now take arrows and indicate direction, then from here, this program of ours will end at this point. That's where they will rejoin. Now look at what we have done. Then we also showed that program is actually heading this way. Checky. Very good. Therefore, you have seen now how we have used all the tools that we have run today on program flowchart, and I am sure you have also changed your mind on that flowcharts are not difficult. You only needed to internalize and accept that they are not difficult, and then do a lot of practice. Therefore, you can try to see what we have done. We have now actually drawn our flowchart start using the ellipse or the oval. Then we have taken the input using the parallelogram. Then we have used the raw bars as decision with following the two rules of yes and no, and or the question. Then we have given the output. We have also showed you, I have also taken you through the process of calculations or process using the rectangle. Then we have also given output using the parallelogram. Then we have used the stop to show that our program has actually ended. And therefore, you can see our topic, that is our lesson, is actually very interesting, and it is also getting more and more interesting. Now, on the other hand, we have complex flowcharts that I have not tackled for now. But complex flowchart use control structures, and therefore our next lesson is control structures. It is in the next video. Therefore, complex flowcharts use control structures, covered in my next video. Therefore, kindly check the links below this video. You will see a link showing you or taking you to control structures. Then we shall also have a link taking you to KCSE Flowchart Revision Guide 2014 to 2019. I have tackled or KCSE question 16. Question 16 is whatever I was teaching you, that is flowcharts. And therefore, I have taken you through all the flowcharts, that is complex flowcharts, for the year 2014, for the 6 years up to 2019. It takes you through the rest of this topic, and therefore kindly go to control structures, and then you go to KCSE flowcharts and practice. For that matter, you'll be in a position to have understood everything. But still, I'll be coming up with a video on pseudocodes, which is part of flowchart. Therefore, don't miss that one. Keep on checking. I'll be doing pseudocodes, how to write pseudocodes. Therefore, thank you very much for watching. If you haven't subscribed, kindly consider giving me a subscription. Also, share my videos to other students. Make sure that students understand these concepts so that we can build our country. Thank you very much. God bless you. Take you through elementary programming principles. That is a Form 3 topic, but the subtopic is control structures. When you talk about control structures, these are statements that are put in place in a program or in the code to make sure that the code works as it is supposed to. Therefore, it tries to eradicate a lot of repetitions or to curb repetition or even to make things easier. Therefore, today I'll basically handle selection. Under selection, we have if then, we have if then else, we have nested if, and then we have case select. Therefore, this one is almost the same thing. The ifs is the same thing, only that sometimes you include else if conditions are more than 2. Then if conditions are now more than, if there are so many, now you are forced to use nested if or case select. Therefore, I'll take you through that one. Then later on, we shall look at iteration. Iteration is also called looping. Looping is also called looping that way, or repetition. Therefore, I'll take you through while loop. Then I'll take you how repeat until works, and also how for loop works, and that is within what our syllabus covers, that is using Microsoft Access. Therefore, we can go to the practical bit. We first of all create a form, a blank form, that is form in design view. Now, once you create a form in design view, you then draw a button, a command button, but I opt to use toggle button because toggle button will not initialize a VBA code, but a command button will actually come attached with a VBA code, which might be disturbing. Therefore, we shall create a button, but we can start by saving our form as control structures. Control structures. Then we start by checking on the selection. Like now, we may have this button. We can call it if then control structure. Therefore, this one will actually be dealing with if then. Then you can go ahead and format that one, that button that way. Therefore, this is our if then. Now, once you have this button, we right click, then we go to properties. Now, once we go to the property sheet, we go to event, then we go to event on click, and then we select that is on click, we select event procedure, then click the 3 dots at the end. Now, this is the code window. This is where we are supposed to type our code. Therefore, if we have a condition that marks if somebody scores 50%, then that is a pass. That is one condition, and therefore we can just use the if then. And therefore, we can start by writing a comment. A comment is an executable statement that makes sure that you understand what is being written in the code, but actually it will not be executed or shown when the program is executing. Therefore, we can just write a comment that we are running if then. That way, you can see it turns green. That is to tell you it will not be executed. And therefore, we start by declaring whatever we want to capture. For example, we want to capture marks. Therefore, dim marks as integer. Integer is a number. Integer. That way. Then we capture our mark. Therefore, our marks equals to value, that is to convert number to that is anything, even if it is text, right? It will be converted to a number. Therefore, input box. Then this is a function to capture marks. Then enter marks. That way. Then we cross that. Then after capturing the marks, we come here and write our if statement, that if marks is greater than 50, then we shall give a message, msg box. That's a function to give message. Then the pass mark attained. That way. Then end if. You have to end if. Because it is one if, we end if one. And therefore from there, we just save this one. And once we save, we can go and execute that one by crossing this. Then we go to home, then run our form. And therefore, in case there is a mistake like this one, we just go and check input box. We skipped T. Therefore, that was a syntax error. It's also good that we have reminded ourselves on the errors. Therefore, that was a syntax error. And therefore, from here, can you press F5, then click. Now you see we have executed this one. Therefore, it will ask for us enter mark. And therefore, for example, I enter 56. Then I click on OK. Therefore, you see the pass mark attained. Therefore, that's how we use if then. Then we can proceed to the next one. Right click, go to design view. Then we can draw another toggle button. Now this time around, we shall run about if then else. This is when now we have more than two. That is more than actually one condition. Therefore, we can just format that one. Then borrow it and give it a different color for that matter. Then you right click, you go to properties, then on click event, on click you select event procedure, then go to the code window. Now this time around we write our comment, this that we are running about if then else, that way. And therefore we start by declaring for example, we can use age, dim age as integer. It's just like dim age as a number, to accept a number. Then we can capture age. Age equals to value input box, then enter your age. Enter your age, that way. Then you cross the two brackets. You are crossing this first bracket and the second one. That's why you have to. Then you come and write a statement if age is greater or equal to 18, then message box, give a message that you are a grown up. Now, if that condition is not met, what message do we get? Else MSG box you are under 18. Then and if that way. Therefore, you can see now we have included else in our statement because conditions are more than we have more than one condition to be captured, and therefore after doing that you close the code window, go home, and first of all you save this, then run. Therefore you can see enter your age, and therefore my age is 16. Therefore you are under 18. Therefore we can capture again 56. You are a grown-up. Very good. Therefore that's how the if then else works. Therefore you can proceed to the next one, and we can still go and draw. Therefore you can draw the other one. The other one is nested if. Now this is used when you have more than that is when you have more than when you have more than many. Actually, let's say when you have many conditions. That makes sense. Therefore let's look at nested if. Now nested if means you are using many ifs, and that's why we are actually calling it nested if, because you are using many ifs. Therefore nested if is not so much different from what we are doing, only that you use many else. Therefore you can just go to this part here, then you can hit that button, then go to our code, and therefore we can start by writing our comment. We are learning about nested if. That's many ifs that way, and therefore we can start by declaring something like age again. That is, now let's use max. Dmax as integer that way. Then we capture the max. Max equals to var input box. Then we can capture our max. Enter any mark between 0 to 100 that way. Then we come to this point and say if max is greater or equal to that is, if it's greater or equal to 80, then we give a message box grade is A that way. Else if max is greater or equal to 60, then MSG box grade is B. Grade is B. Else if max is greater or equal to 50, then MSG box, grade is C, else MSG box, take a supplementary, that way, then and if. Now let's see what we have so far with that one. We save that, then close the code window, then go and see, therefore enter the mark 42, therefore take a supplementary, then we can try again. We take something like 56, grade is C, take another one, take 85, grade is A, take something like 45, take a supplementary. Therefore you can see the difference between the three ifs, that is if then else, and nested if. Therefore we can proceed to the next one. The next one is go to design view. The next one is case select. Therefore you can also talk of case select, so that we can actually finish on the types of that is the examples of selection. That is, this is now selection category of selection. You can just give it a good look there. We are in selection here, so that we can now go again and look at the loops. That way. Therefore we are in the selection, therefore we can add our next selection example, that is case select. Now case select, we just go again to design, then we take this one, then we can now write case select. Now case select is the simplest. If you can ask me, among these ones, case select should be the simplest. Therefore to tackle case select, it is not so much difference from the others. Therefore you right click again, go to properties, then on click here, then you click this select. Remember, you can get these codes on my website. I will post the link down there. You can download these codes there, and also the database that I have used. Therefore for case select, we start by writing the comment that we are running about case select. Now case select, we have agreed it's the simplest. Therefore what you need to know is the keywords to use. Therefore first of all, you shall dim is to declare what you are doing. Therefore you shall dim max as integer, dim max as integer should turn blue. Then from there we shall capture the max again, just like we have done to the others. Max equals to input box, we have skipped var to make sure it is value, it is number. Therefore input box, enter any mark between 0 to 99. That way there is somewhere we have, or we haven't put crossing quotation mark. Therefore compiler reports we have an error. Therefore then from there we declare the select that is case select statement. Therefore, we start by writing select case. Now, what we have declared marks. Therefore, then case is, if case is greater or equal to 80, then what do we get? Then we get a message box that you have an A, brain. Then we go on and write that now case that is case 60 to case 70, then MSG box, you have a B brain. Now we use the university system. Then case 50 now to 59, then that is case list 59 to 59, that way MSG box, you have a C brain. Therefore, from there we can have else case, okay, then case else MSG box, take as supplementary. Then we end case by end select. Therefore, that's how case command is written. Therefore, you can just go to save. Now, once you save, you run that one. See how it happens. Therefore, when I click case, like that, you see that enter mark. Therefore, if I enter 56, therefore you have a C plane. Then you can enter something like 23. Yeah, take a supplementary. Then we can test 68. You have a B plane. Therefore, that's how the selection works. We have looked at if then control structure, nested if then else, and case select. Therefore, we can now proceed to the looping. We look at how looping also works. Therefore, we can draw looping. We can look at looping. We edit that one to make it looping. Therefore, let's look at looping. Now, looping, we shall look at repeat until, while loop, and we shall also look at the for loop. Therefore, we can start by looking at the for loop. That is for loop. Go to design, then we draw a toggle button. Remember, I'm using toggle button because it doesn't have attached code, which will actually confuse you. Now, for this one is for loop in access, and therefore the for loop will look like this. You save, you right click, go to properties, then on click we are using event on click. Then we can start by, can now take this one up here, can write our code up here. Therefore, We want to start by commenting that we are doing for loop. Now, when we are doing for loop, it actually helps you to avoid a lot of unnecessary repetition, and therefore we shall use days of the week. Like for example, that is let's use months, because they actually make us more to understand, because there are many. Therefore, we can start by declaring dim the month. Then we shall come down here and say dim months, now in plural, dim months as collection. Then we go ahead and then say set months equals to new collection. Then we can have months dot add, then you add the month January. Then you now copy this. There is no need of rewriting. Copy, then paste. You change this one to February, then paste again. Control V, change this one to March, paste again. Change this one to April. Then you can copy this from April downward. Again, now we know this is May, this is June, this is July, August. Again, you paste. This is September. This is October. Then this is November. Then December. Then we have December. Then after doing that, we now write our for loop here, that for each month in months now, for each month in months, as we have declared there, MSG box, that is function month. Then next month, so that now when you reach January, it goes to the next month by clicking on next. Then set months equals to nothing. When it reaches the end, then nothing will be displayed. Therefore, remember, you can get this code and this database the way it is for free on my website. Just open my website, then go to other downloads. We'll be in a position to get it. Therefore, this is how that code looks like. That is for the for loop, and therefore we can try to see what we have. After writing that, you can close now this, then save, go home, then run. Therefore, you can see on clicking the first one, it brings January. Next, it now runs to the next March, April, that way, until when it reaches December, it executes, because you have written that when you reach December, display nothing. Then from there, we can go ahead and look at our next looping. Our next loop is where we can look at do until, that is repeat until, but in Microsoft Access we shall use do until. Instead of the word repeat, we shall use the word do, and therefore you can just write do until. Now do until is just the same as repeat until, and therefore you can just go and do that way. Then just like we are doing to the others, right click, go to properties, then on event on click, we are using on click, then you click the 3 dots. Now once you click on the 3 dots, you are where to go. You can now go to our code. We start by commenting that we are doing do until or repeat until. Then I shall just write a simple code whereby if a certain number entered is equals to a certain constant, like we can say a equals to 10, then we shall check a condition whereby when a is greater than 15, what should happen? And therefore we can declare our integer as a and say a, our x, the one we are used to, x equals to 10. Then do until x is greater than 15. Therefore you'll expect 11, because 11 is actually will be an increment of 1 from 10 up to 15, where 15 is. Therefore let's look at that. Therefore do until x is equals to 15, and this condition is actually false. Therefore we can mark this and say this condition is false. It is actually false according to that one, and therefore our x equals to x plus 1. We want an increment of 1, and therefore then we get a message box. The values of x are, then usually use ampersand x, and then from there it will loop. You just include the word loop for it to go to the next line. Therefore we are checking this condition, which is actually false according to that statement. Let's see what we have. Therefore we can just save, then run, then close this one, then save, go home, run. Therefore you see now the value x is 11, 12, 13, 14, 15, 16. Then it terminates from that one because the condition is actually false. Therefore let's try to look when the condition is true on the same, but this time around the condition is true. Therefore we shall rewrite the code. We just go to view, then our code here will actually change. Therefore our code will be, remember we are doing this do that is until. Therefore we shall just write that x equals to 10, then do, if x is 10, do x equals to x plus 1. We are incrementing with 1, and then we shall get a message box. X is, then we give ampersand x, that is the output statement. Then from there it will loop until when, then we give the condition loop until x is less than 15. For example, this condition is true. Therefore let's see what will happen. Loop until that. Therefore this is how you write the loop. Remember to get these codes and the database on my website. Then we save this. Then let's see what happens. What do we expect? Therefore you expect 11 to get 11 as the answer, and therefore you get 11. Therefore when you click you just get 11 because the condition is actually true, and therefore you expect to get 11 as the answer. Therefore you can still get this database and the codes on my website for practice purposes. Therefore you can go ahead and look at the while loop. If I can go and get the while loop. Now you shall test the same condition using do while. the same we have used to see whether I can get 11 as the answer for that condition, where our x equals to 10, and we want to loop until that one actually exists. Therefore, go and check this. Go to this button here, draw. Then this time around is we are actually doing the while loop, do while. Therefore, this is do while, and therefore do while goes like we are going to see. Therefore, just do as we are doing to the others. Right click, properties, then go to event on click, then you hit this button, then we can zoom and see what we have. Therefore, start by comment. We are doing while loop. Therefore, these statements will also help you when viewing this code. You know which code is doing what. And therefore, we just write do while. Do while you give the condition. Our x is less than 5. That way. Then our x should be x plus 1. Then what will you get as output? MSG box. You just say the value of x is, then you usually write an ampersand and that variable x that way. Then after that it should loop. Now the loop here, the word loop is actually the one that is actually instructing the compiler that after this condition is met, then you go to the next condition. Therefore, what do you expect? Do while. Therefore, where x is less than 5, like for example, if you start from 0, then it will be 0 plus 1, you get 1. Then it becomes 1. It was 1 plus 1, 2. 2 plus that way until now we get 4 as the last value. But it should not give 4, it should give 5, because it will be 4 plus 1, 5, and then should terminate. Therefore, let's see what we actually supposed to get. Therefore, you can cross this, then save and run, then click. Therefore, you can see our first value is 1. Then should give 2 until 5, 3, 4, 5. Therefore, it should terminate because actually the condition is less than 5 according to that, but it is 4 is less than 5, but the increment is 4 plus 1. Therefore, the last value there for that matter will be actually 5. Therefore, that's how we look at the control structures. And as you have seen, we have gone through the required control structures in our syllabi, that is Kenya National Examination syllabus. You're supposed to cover if then, nested if then else, case select. Then we need to cover for loop. We need to cover do until or repeat until, then the while loops. Therefore, thank you very much for watching. Remember to subscribe if you have not subscribed. If you have a question, you can really post on my description. Therefore, again, hi guys, I would wish to take you through 2019 KCSE Computer Paper 1, question 16. In this session, we shall tackle question 16, and then we shall be in a position to know how the question was supposed to be answered. Therefore, in section B, we usually have the instruction as answer question 16 and any 3 questions from this section, but I'm interested in question 16. Therefore, question 16A, explain the term dry running as used in program development, 2 marks. Then we have part B, explain 3 properties of an algorithm. Therefore, we go straight and answer that one. Therefore, dry running is also called desk checking. It refers to going through the program while still on paper before entering it into program editor. This helps the programmer to detect the most obvious syntax and logic errors. Therefore, dry running is just going through the codes before you actually copy them or type them in the computer. Then question 2, we have properties of an algorithm. Therefore, when I talk about an algorithm refers to a series of steps followed in solving a certain problem. Therefore, an algorithm must satisfy the following properties. Number 1 is input, explained as follows. The algorithm must have input values from a specific set. Then output, the algorithm must produce the output values from a specified set of input values. The output values are the solution to a problem. Then we have finiteness. For any input, the algorithm must terminate after a finite number of steps. Then we have definiteness. All steps of the algorithm must be precisely defined. Lastly, we have effectiveness. It must be possible to perform each step of the algorithm correctly and in a finite amount of time. That is, its steps must be basic enough so that, for example, someone using a pencil and a paper could carry them out exactly and infinite amount of time. It is not enough that each step is definite or precisely defined, but it must also be feasible. Therefore, those are some of the properties of a good algorithm. It must have an input, output, fitness, definiteness, and effectiveness as explained there. Therefore, we can proceed to the next part of the question. And therefore, the next part of the question is part C. To qualify to get a driving license, an applicant must be 18 years or over. 10 candidates applied for the driving license test. Draw a flowchart that would read the name and age of an applicant and display the names of those who qualify. Therefore, what we need to do is to go to a Microsoft Word new page. Then we need to draw that flowchart the way it is supposed to have been drawn. And therefore, we first of all insert the shapes that are supposed to be used. Therefore, we have the shapes that are supposed to be used. Then we also have the input. Then we need to have another one. We have the flowchart tools here. Therefore, we have the input. We also need to have the input there. Then we must have a decision somewhere. We have to get a decision. Then, on the other hand, we shall also have we shall have a counter, because we shall actually be doing some iteration. So we can have a counter there because of some iterations that will be actually be involved. Then we can also have another output here, that point, and then also we shall have another decision here. Then after having that decision, we can terminate our program that way. And therefore, after having done that, we can combine the flowchart by showing the flow that way. Then we go to the next one. We also show the flow. We show the flow. Then from here we also show the flow using the arrows. Then from there we also continue showing the flow that way. That is the flow of the program. We just go back, insert shape, we take the arrow, then we drop it that way. Then from there we have also another flow here. Then we also have another flow. Therefore, the direction is very important because you are actually showing the flow of that is flow of the activities. Then from there, from here, we need to go this way. And to go back to the counter, we also need to go this way to the counter. Then we can make this one a bit thin, also this one. Then after doing so, you can go back to insert shape. Then we shall have an arrow going that place, and also another one going that place. That way. Then we also need to have an arrow going this way, and also another one going up to this point, that point. Then we shall have another one directing to that point there, that way. Therefore, now we are done with the structure of our flowchart the way we need it to be. Therefore, we can now go down typing as we explain. Therefore, you right click here, you go to add. Therefore, this was start of our flowchart. Then we need to initialize the counter. We have been told that to qualify to get a driving license, an applicant must be 18 years and over. This is a decision. Then 10 candidates, this is where the counter is coming in. We have to count up to 10. And therefore, that's why we are initializing the counter here. And therefore, we can just say count equals to 1. We shall start from number 1, since we cannot start from 0. Since we have now 1 to 10 to have exact. Then from here, we need to read. We have been told from the question that draw a flowchart that would read the name and age, and therefore we are now reading the name and age. Therefore, you can just write here input name, comma, age. We are now reading the age, that is the age and the name. Then from there, we have initialized count of 1, and therefore we shall have counter plus 1, so that if it was 1, it becomes 1 plus 1, it becomes 2. Therefore, if it was 2, it becomes 2 plus 1, it becomes 3. And therefore, after now input name, and we are inputting name, comma, age, then we shall have our decision here. We have been told an applicant must be 18 years or over. That means we have to ask our decision, is age greater or equal to 18? Then you put a question mark. Therefore, that's how it should be. Is age greater or equal to 18? That way. Then we must now have a no and a yes, and therefore, if it is no, then it goes to this point and checks the counter. But if it is yes, it prints the name here. Therefore, at this point we shall have a decision print or output. We shall have output name. Now it will output the name. Here it will output the name. Since now here the condition is true, and therefore to show that the condition is true, we go to insert shape, then we take a text box and write now we can have yes, that is condition is yes. Boolean means yes or no, and therefore you can just go here and remove the line. Therefore that is our yes. Then if the condition is no, on the other hand, we just put our no here. Therefore if our condition is no, it is not true. Remember we have talked of boolean yes or no. That means if it's no, then what will happen, the counter goes to checking on the name, and therefore the next decision is to check whether the count is up to 10. Therefore is count equals to 10 question mark, that is should be equal to 10. From the question paper, 10 candidates apply, therefore counter should be exact 10. Therefore we are talking of is counter up to 10. If it's no, then if it is that is, it should check whether the counter is actually less, for the counter to continue. Therefore is counter less or equal to 10, that is the count. If the count less than 10, if yes, if it's less, then it goes and increments. Therefore it will increment here, and therefore if it's yes, then count equals to count plus 1, that way. Therefore that's how it will look like. Then on the other hand, this is if it's I can just go and copy this, that is if it's yes. Remember when copying this, you are copying this, you click on the line, then copy, then we shall paste. Therefore once you paste, you can carry this. Therefore this is up to this point yes. If it's yes, then it goes that is if count is less or equal to 10, yes, it goes this way. But if it is exact 10, then it exits. Therefore this one goes now to we take no here, we click on the line to copy, then go home, copy, paste. Therefore you can now take this one to this point here. Therefore if it's no, then the program stops. Right click, add text, that is stop. Therefore the program stops. Then on the other hand, if it's yes, if example count is 1, then it becomes 1 plus 1, it comes 2. Therefore it comes again here as 2. Then checks is age than 18, no, it checks again, count is count up to now 2 plus 1, 3 up to 10. Therefore that's how now the program will actually look like. Therefore this is how the program, the flowchart looks like, and therefore you can now try to see how our flowchart was. Therefore we have start, then we count 1, then we input name and age, then we have the decision is age greater or equal to 18. If yes, then it outputs the name. If no, then it goes to the counter again and repeats itself. Therefore that's how the flowchart was supposed to have been drawn. That is for that question, that is for this one, and then you now score the you score the 7 marks. Therefore that's how question 19 for 2019, that is question 16, sorry, for paper 1 2019 was supposed to be tackled for the student actually to get all the marks. Therefore thank you very much for watching. See you next time, as we shall be doing 2018 downwards all the way for the last 5 years, just like we have been doing in other papers. Thank you. If you have not subscribed, kindly consider to subscribe. Hello friends, I would wish to take you through KCSE 2018 Computer Paper 1 question 16. Remember we have done 2019. It is just in the playlist. Therefore, let's go to question 16 of Computer Paper 1 year 2018. And therefore, the instructions for section B are always answer question 16 and any other 3. But we are interested in question 16. Remember, question 16 is mandatory, it is compulsory. Therefore, with the aid of a flowchart, describe a loop control structure as used in programming. 4 marks. And therefore, we shall go and answer that one. Therefore, a loop, we need first of all to understand what is a loop. A loop or looping, or it's also called iteration, it's also called repetition, is a control structure designed to execute the same block of code or a set of codes again and again until a certain condition is fulfilled. Therefore, it is a matter of repeating something more than once. It is used where the same operation had to be carried out on a set of data many times. Example, assume you want to calculate the average marks of 5 subjects for a whole class. Let's assume a whole class of 28 students or even 10 students. Therefore, loops include, we have the while loops, we have the repeat until or do until, we also have the for loop. Now, to understand more on loops, I have done a practical video. You will get the link below this video. There is a link on how to do them practically. Therefore, the question reads using a diagram, but I have seen it is wise for me to explain what is a loop. Therefore, if you look at this extract, this is not a complete flowchart. It is an extract of a loop structure. A loop means it must have a condition, and therefore from there you can see there is a condition, and therefore if the condition is true, some statements are executed, and if the statement is false, then the loop exits. Therefore, that's how actually a loop works. You can go on and watch 2019 KCSE question 19 above. You will see how a full loop flowchart is drawn. Then from there, we can go to part B of the question. Therefore, study the following pseudocode and answer the question that follow. Therefore, this is a pseudocode. Therefore, the question is, state the purpose of the pseudocode, 1 mark. Therefore, the pseudocode starts, then it enters value 1. It also enters value 2. Then it executes an if-then condition. This is a selection condition type of control structure. Therefore, if value 1 is greater than value 2, then maximum is value 1. Therefore, it is actually comparing if value 1 is greater than value 2 and then outputs the maximum value. Else, it gives the other value that is actually greater. If the value 1 is not greater, then it means value 2 is greater. And therefore, the purpose of the flowchart is just to compare the value. Therefore, the answer is the purpose of the pseudocode is to compare two values and output one of the two which is greater than the other one. Therefore, that is the answer for that one. Then we can proceed to part 2. We were in part B1. Therefore, draw a flowchart equivalent to the pseudocode. Therefore, we shall be drawing a flowchart that will start. Of course, it will end, but in between, it will actually have an input. Then it will have a condition. It will also have some output, and that is some codation also. Therefore, let's go ahead and draw that one. Therefore, we shall go and insert a new page. Then once we insert a new page, we make sure that our page orientation from layout menu is portrait. Then we can go ahead and draw all the required shapes. Therefore, we shall have that one for start. Then we shall also have the entry. That is, we shall have to get the entries of that is our entries. Our entries, we use a parallelogram or a kite that way. Then we shall also have two decisions. Remember from the question, we shall have two decisions. Therefore, you can have decision 1. We shall also have decision 2. That is to compare if the first value is maximum, and also to compare whether the latter is the greater value. Then from there, we shall have the output for this one and output for the other one, and then the loop will exit. And therefore, we shall have the output here for the first one and also the output for the second one. Then we can remove the colors by clicking on the design that way. Just click the design. We just click that one. Therefore, I have also done another video on how to draw flowcharts in Microsoft Word. You can also get the description. Therefore, after having that one, we shall now have the display here. We shall have our display, and then our flowchart will end. Therefore, we shall have stop. Then from there, we need to go and draw this. Therefore, we shall have this arrow going to that one, that way. And then we shall also have an arrow going to this one, that way. We also have another arrow going from this one to this one, that way. Then from here, we shall have something we call a connector. You can have a connector, a small connector, just a small circle here. Then you can also remove the that one. Then from there, we shall have a line. It is an arrow from this one to the connector. One arrow from that one to the connector. Insert shape. Can have an arrow here heading that way, and also a line showing that this is connecting to this one. Insert shape, then you can have a line that way. Therefore, that one is showing that this is going to meet the other one. Then we have this, then arrow heading to that. Then from there, the arrow will show us that our direction is this way after the connector. Therefore, you can see the use of the connector. This one should not be very far away from the other one. Then from there, we shall now have this one again going to stop. Then we shall have now this one. Then it must go to one of these. We shall have this one, that one heading to that. Then we shall also have an arrow showing that our program is actually flowing. Therefore, we should not have any discontinuation of that is discontinuation of this one. Therefore, from here we shall actually have to get the display, and therefore we have to get this the rating here. Therefore, we have start, and then we can also have stop on the other hand. Stop. Then here, try displaying. Therefore we shall be displaying the maximum. Display the maximum. The maximum will be displayed there. Then here we shall have this is true, this is false. Therefore we shall have at this point this is no or false. Therefore we just go to that one and remove that. Then here we have the condition. The first condition is value 1 greater than value 2, then question mark. Is that one, is value 1 greater than value 2? If it is true, then we can have the condition here. That is, if it's yes, this is yes. If I just go to format, then we remove the outline. If I can still have this one, copy this, go home, copy, paste, then you can take one to this point here. Therefore this one again, now you can copy this, copy that, then right click here, then add text, then paste. But this one will be now vice versa. No, then it will check whether its value 2 is now greater than value 1. That way. Now for this one will be, is value 1 greater than that. If it is value 1 greater than value 2, yes, then it will just say from there. Then if it is true, if value 1 is greater than value 2, then it will be maximum equals to value 1. Then on the other hand, if it's not true, then it will be, is value 2 greater than value 1? Yes, then it will display that maximum is value 2. Then from here we shall have the entry here. Therefore we shall enter values 1 and 2. Therefore it will enter value 1 and 2. Then it will come to this part here and execute. Is value 1 greater than value 2? Yes, then it means that the maximum is value 1. Else, if it's no, then it means the value 2 is greater than value 1, and if it's yes, then it goes to that one, that is maximum value is this. Then it will go down and display the maximum value. Then the program will actually stop. Then what if that this one is not, the condition here is not true? What happens? Therefore, on the other hand, on the same note, on this one, somebody else may opt to draw it in another version. Draw that, then opt to draw the kite, the entry, that way. Then draw a decision, 2 decisions. To draw 2 decisions, you can copy paste, then bring it down here, and then from there draw the termination. Draw the termination here. Then after doing that, draw the outputs here. That's how somebody else may opt to do it. that way. Then after doing so, they then can opt to combine. You can opt to actually combine the flowcharts by going to this point here, that is insert shape, then take this arrow and draw that is the insert shape, take the arrow, then draw the arrow, then again take this one, draw the arrow that way. This again insert shape, take the arrow that way. Then after doing that, can still come to this point and then draw a straight line. Now here we forgot to include the output. So I can just put the output, or the output is there. Then on the output, what is the output can be drawn there. And therefore we shall have an arrow going down. That way. That is the arrow from that point. Shape, we get an arrow that way. Then from there, we shall have now this straight line of ours. Then we have shape, and then for example have this going to that. Also have another arrow going to that one. Also have another arrow for this one going to this one. That is for the display. This one will actually be outputting, and therefore it should be outputting towards this, towards that one. That way. Then this one's the direction for this one. For this one should actually that way. Therefore it should be showing the direction that these ones are heading. Then we can also go to insert shape. Then we have this one going to that. Then we also go again insert shape. We have this one going to that one. Then also this one again heading to that one. Then we can now have our outlines that way. Then we have our rust arrow here. This one going to that point. Therefore, this is another version of how somebody else would have drawn the flowchart, and therefore we can just give it some text. This is start. Then this is input value 1, value 2, value 1 and value 2. Then from here, this one now will be value 1. Is value 1 greater than is value 1 greater than value 2? Then question mark. Then this one now will be vice versa. Is value 1 is value 1 now less than value 2, or whether value 2 is greater than value 1, it is the same thing. Then we have add text. We also have add text. We also have add text, and therefore here for this case we shall have maximum equals to value 1. For this one, maximum will be equal to value 2. Then this one will be display output maximum, that way. Then this one will be stop. This one will be stop. Then we shall have now at this point, this one will be no. Then you got to shape out and all time. This will be no. Then this one will be also false. You may opt to copy this and then take this here. Therefore, it will also be no. Then can paste this here. This one on the other line, on the other side here. This means this one will be yes. Then paste again. Then for this one also is will be true. This one will be true at this point here. And for this one also will be actually true. This one here. So that one will be yes, 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 like that. Therefore, somebody else would have drawn the flowchart in that manner, that way. And then for me, both are correct, because you actually need to just be creative. Just be creative enough and be in a position to earn the marks. Therefore, that's how you are supposed to earn those other marks. That is the 6 marks. And therefore, that's how you are supposed to actually answer the question. You can either, you would have opted to use the first method this way to have the values drawn, or alternatively you might have opted to use the second method of making sure that you actually get the 6 marks. Therefore, thank you very much for watching. Consider watching 2019 question paper. It's also uploaded, and in my next videos I will be doing other earlier years. Therefore, I will be doing 2017, 2016 and 2015 downwards. Therefore, if you have not subscribed, kindly consider to subscribe. Thank you very much. God bless you. Okay, hi my friends. I would wish to take you through KCSE 2017 Computer Studies Paper 1, question 16. Remember, we have done 2018 and 2019. They are on the playlist. You can search for them above there. And therefore, 2017 question 16 read as follows. Remember, instructions for section B are always that answer question 16 and any other 3, but we are interested in question 16, and question 16 is compulsory. Therefore, state 2 qualities of a good pseudocode. We shall not actually state 2, but state many. Therefore, these are the answers expected. That that is, a good pseudocode should have their statements must be short, clear and readable. That is, the statements must be short, clear, and readable. Number 2, the statement must not have more than one meaning. We say they should be non-ambiguous or not be ambiguous. Ambiguous is a statement with 2 meanings, or it is not actually clear. Then number 3, the pseudocode lines should be clearly outlined or indented. We actually use the word indented. A pseudocode must have a begin and an end. Rather, it must have start and stop. That is, a pseudocode should show clearly the start and stop for executable statements and the control structures. Number 5, the input, output, and processing statements should be clearly stated using keywords such as print, read, input. You can also add output in capital letters. Yeah. Therefore, those are some of the answers. You would have chosen 2 out of that. Then that is question 16 part A. Then we have, with the aid of a flowchart diagram or diagrams, describe each of the following program control structures. And there is a video I have done on practical bit of program control structures. Just check the description below this video. You can be in a position to look at the various program control structures for easy understanding. Therefore, with the aid of flowchart diagrams, describe each of the following program control structures. Sequence, we have 3 marks. Then we have selection. Therefore, we have selection and sequence. And therefore, that is in Form 3, you opt to have learned about elementary programming, and therefore you have sequence, you have selection, and you have looping. Therefore, sequence control structure, the computer reads instructions from a program file line by line, starting from the first line sequentially towards to the end of the file. This is also called sequential program execution. Therefore, sequence. Therefore, the diagram is this one. We have start, then the computer reads statement 1, then it reads statement 2, it reads all the way up to statement n. That means if there are 9, n should be 9 there. Then it ends. Therefore, if you are told to explain, just explain that the computer reads line by line from start to end. Then selection or decision control structures. The selection involves choosing specified group of instructions, stroke statements for execution. In selection control, one or more statements are usually selected from execution, depending on whether the condition is true or false. Therefore, to explain in simple terms, just explain that the computer works on a condition of true or false. We call it Boolean. The condition must be Boolean. Boolean means it is either yes or no. Therefore, for example here, we want to know whether x is greater or equal to 20. In this case, the condition is true if x is equal to or greater than 20. Any value that is less than 20 will make the condition false. Therefore, that is the Boolean statement we are talking about. Then, in the question paper, we have been asked to use a diagram or a flowchart, and therefore this is not a full flowchart, but an extract of a flowchart showing if-then structure. Remember to watch the other video. Practically, you see how the if-then-else works. Therefore, the condition is true here, and if the condition is true, execute statements between then and if. Else, the condition, the continuation of the program. For example, else executes. Therefore, that is an extract of if-then statement. Don't forget to watch that video. It will actually enlighten you and open you up to see how this condition practically works. Then we can proceed with our question. We can go to this question. Draw a program flowchart that would accept 3 numbers and find their sum. if the sum is greater than 200, it adds 30 to the sum. Otherwise, it subtracts 20 from the sum. The program should then display the results. Therefore, that is 7 marks, and therefore we shall be using the statement, the selection statement, that is if then else. That's what actually the examiner is testing. And therefore, for that case, we shall go and launch our Microsoft Word, then go to layout, make sure our orientation is actually portrait, that is a long paper. Then we shall draw our flow chart. We just go to shapes, then we draw the start button, that is the start. Then you click this to eradicate that. Then we shall have the entry, that is the input. Therefore, the input, we usually use the parallelogram, this one here, or robust. Then we want to process. We are processing the 3 numbers. Therefore, to process the 3 numbers, you need this. Therefore, this is start. This is parallelogram or robust is used for enter inputs. Then this one is used for processing, and it's called the process. And from there, we shall have a decision. Therefore, we shall have a decision down there. You can still click that. Then after the decision, we shall have the 2 conditions for adding 30 and for minusing 20. Remember that. Therefore, if condition is true, we shall actually have a process showing how that one is accomplished. On the other hand, we shall also have another point there, that is for if condition is, that is if condition is true, if condition is false. That is what we shall actually be doing. Then from there we shall have an output, that is we shall display our results. Therefore, we can go to insert shape, then we draw our parallelogram that way. Then we after doing that, then our program can terminate, our program can stop. Therefore, this one is also used for to start and to stop. Therefore, first of all, we have arranged our flowchart the way it should look like. Therefore, we can draw it as I explain. Therefore, start, then you draw the arrow to start that way. Then also show that the program is actually dropping or flowing. Then this one we shall go to that, showing that our program is still flowing. Then from there we shall have our condition if it's false, that way. If we can have our condition if it's false on one hand, our condition is if it's true, and therefore here we can have our condition. You can see that our condition there is true, our condition on the other side is false, that way. Then from there, these conditions of ours, we shall go to this to display. Therefore, this one goes down. Then usually you have roundabout a connector, and this one can be somehow. You have roundabout a connector. Therefore, connector will be used here, and therefore this one will just go to that point. Then we shall also have now this one also going to the connector, showing you that they are actually meeting here before they proceed. Therefore, can just go up again to format, make sure they have the same color, that way, including the connector. Though the connector can remain the way it is, but there is not much trouble for doing whatever I have done. Then so now drops down. Then once that one drops down, also this one now goes to the end of the program. Therefore, we have drawn the structure of our program, and now we can start feeding the program. Therefore, you right click, then we have start. Then on the other hand, we have now to capture our 3 values. Therefore, the question reads, draw a flowchart that would accept 3 numbers. Therefore, you can have x, y, z, x, y, z. Therefore, those are our values, but now we need to key in the word input or enter. Therefore, we are entering the 3 values. Then, after entering our 3 values, we go to the next, find their sum. Therefore, we go and find their sum here. Therefore, we shall just right click, then go to add text, then write sum. Sum is addition, therefore equals to x plus y plus z, that way. Therefore, those are our, we have done that. Therefore, you can see how the marks are being. We are following the question step by step. If the sum is greater, now that is a condition, that is a decision. If, then, that is a decision. And therefore, if the sum is greater than 200, therefore we go to that point and ask ourselves, is the sum, now sum has been calculated. We have calculated the sum here. Is the sum, therefore our condition is our sum greater, that is greater than 200, then you put a question mark. Therefore we actually can just go, see no spacing, then we can center this. Therefore we are now asking ourselves, is sum greater than 200? Therefore I shall have one side saying yes, because it is Boolean. Boolean means yes or no. On the other side you shall have no. Therefore just go and take a text box, therefore and draw. Therefore we can just say this is yes. There is no much undo by doing that. On the other hand, take another one, then draw this one. This is no. You can also use F and T, that is true and false. There is not much ado by doing that. Therefore, you can see. Therefore, let's go and answer the question from the question paper. If it is greater than 200, it adds 30. Otherwise, that is to say, if it's no, then it is subtract 20. Therefore, let's go and do that. Let's go to the side of no. On the side of no, you just right click, and therefore you have said sum will be sum minus 20. That is if it is false. On the other hand, you have been told, then it will be sum equals to sum plus 30 or 30. You see how simple that one is to scoop the 7 marks. Then from there, it will display, and the program is, the flowchart is complete. Then it should display. Therefore, it should output sum. Otherwise, it terminates. The program says by stop. Simple, as simple as that. You have seen how I have drawn that flowchart without struggle, without actually much struggle. Therefore, if you read the question, you will see that I have scored 7 out of 7 from the explanation, the way the question is. Therefore, we are drawing a flowchart that would accept 3 numbers, x, y, z. If sum is greater than 200, it adds, therefore, sum plus 30. Otherwise, it is sum minus 20. Then the program displays the output, and that is the whatever you are expected actually to do. And therefore, let's see, okay, that is the last part of the programming, that is question 16. And therefore, you have seen that it was very easy to answer that. Therefore, thank you very much for watching. Remember to subscribe if you have not subscribed. You can share my videos to other students so that they can also benefit and know how to tackle flowcharts. On the other hand, I will see you in the next video. That is, I will be doing 2016 and 2015 question 16 on paper 1. Thank you very much for watching. God bless you. Hi guys, let's carry on. We are in 2016 KCSE computer paper 1. Remember, we are tackling question 16. Question 16 is from form 3, that is elementary programming, and as the instruction goes, always in section B, answer question 16 and any other 3. Remember, question 16 is compulsory, and therefore we have so far tackled 2019, we have so far tackled 2018, we have also tackled 2017. Now we want to tackle 2016, and therefore figure 1 shows a flow chart. Use it to answer the question that follows. Therefore, this is the flow chart that was there in the year 2016. The way it looks like, it is a looping. It is actually a looping control structure used there. On the other hand, it can still also qualify to be selection because it is also using if then. Then from there we can go to the question. Therefore, we have 9 marks. Interpret the flowchart. Now, when you are told to interpret, you are actually asked to explain what is going on in that flowchart or what is expected. And therefore, to interpret this one, it is very easy. Therefore, you are supposed to explain that the program, that is the program launches, then prompts or asks the user to enter value n, that is where n equals to 1. Therefore, it is a variable n with the value of 1. Then it is also asking for a variable called base, which is 2 with the value 2. That is a variable or a memory location base with value 2. It is also asking for a variable power, which is 10. Then it is also asking for a variable called answer or ans equals to 1. That is value equals to 1. Then it processes ans multiplied by base. For instance, here, since the base is 2, it will multiply 2 times 1. You are supposed to interpret that. Then you go on and say it will make a decision whether variable n equals to variable power. And if the condition is not true, that is variable n is not equal to variable power, then a variable n up there, which is for now is 1, is incremented with 1, and the condition again begins here. Then if the condition is true, that is variable n equals to variable power, then the screen, this is assigned to show the report, or that is the output. Then the output is given as the ans, that is it will give ans times it will give ans times base as the output here. Then the program stops. As simple as that. You only need to understand what is going on the program. Otherwise, when you are asked to that is interpret, you are supposed to explain or show what is actually going on in the program, indicating the outputs that will be given. Therefore, you would have scored 9 marks by just interpreting and showing how those things work. Then, on the other hand, write a pseudocode for the flowchart. Therefore, we shall be writing the pseudocode for that program, which is very simple. It is actually easier to write a pseudocode rather than drawing a flowchart, since pseudocode is just English-like statements that are not actually very much complicated. Therefore, let's launch Microsoft Word. Then once we launch Microsoft Word, we shall be in a position to do the necessary, that is, we shall actually draw the pseudocode. Therefore, let's do that. Therefore, this is our Microsoft Word. Remember, a pseudocode must follow some conditions, like it must be indented, it must use the keywords like start. Therefore, we shall start. Now, once you start, our program is starting by processing. Therefore, you can process. Therefore, you're processing n equals to 1. On the other hand, we also have base equals to 2. Then we have power at the power 10. Then we have ANS equals to 1. Therefore, that is the first part. You can just highlight, then click on space, so that at least you can save on space when you are doing in Microsoft Word. Therefore, this is our keyword. Start here. You can make it large. Then, after now doing that, we have that ANS equals to ANS multiplied by base that way. Then if, now we get the condition if, therefore you are now getting to a condition here. If, therefore if n equals to base, if n equals to base, then remember if goes with then we give the condition. The condition is if that, then we first of all give the correct condition. Therefore print or output ANS. Therefore that's what you are really doing. We are outputting, you can make these capital letters. We are outputting ANS. So this one can be made bold. Also this one, to show that they are keywords. They are actually, therefore if n is that, then output that. Else, which is also a keyword, else, you can also bold this. Therefore else, if n if n is not equal to base, what happens? According to our condition, it will be n equals to n plus 1. That is what it will happen. Then from there, it will now repeat. Else, you can still do here. Else that, then repeat. Then once it repeats, it ends. And if, because you have one and if, therefore you have that and if there. Therefore this one is not supposed to be bold. Then from there it will stop. The program of ours will actually stop. But you also need to indent these ones. Make sure that it is somehow indented for readability purposes. If our program would have wrote something like that, yeah, that way. Therefore, our program could have wrote something close to that one. Therefore, this is how you would have written the pseudocode for that process. Then you also score 6 marks. Therefore, it was as easy as that, but you need to do a lot of practice so that you can be in a position to understand all this. Therefore, thank you very much for watching. Remember to watch 2019, to watch 2018, also to watch 2017, so that you can be in a position to follow the KCSE trend on how question 16 is set and how it is answered. Thank you very much. God bless you. Continue with 2015 KCSE Computer Paper 1. That is question 16, as we have done in our previous videos. We shall still tackle question 16, which comes from Form 3 Elementary Programming. Therefore, answer question 16 and any other 3. We are just interested in question 16. Therefore, part A, list 4 web programming languages. Then part B, state 4 ways in which a programmer can make program code easy to follow. Then part C, we shall draw a program flowchart to represent the following pseudocode, 9 marks. Therefore, the program begins. Then we have where scores exist, that is whether there is any marks or not, that you initialize sum to 0, initialize counter to 0, input a score, increment counter by 1, add score to sum. If there are more scores to read, compute average as sum divided by counter, then print the average, else input next score, and if else print no records exist, end while, that is end. That is a complicated flowchart, but we shall be in a position actually to handle it. Therefore, let's start with the first question. List 4 web scripting languages, and therefore we have several web scripting languages found in the market today or in the world, but most popular ones, we have HTML, which stands for Hypertext Markup Language. We have JavaScript. We have the upcoming cascading style sheets or CSS. We also have VBScript. We have XML, which stands for Extensible Markup Language. We also have PHP, very popular. It stands for Hypertext Preprocessor. We also have Dreamweaver, front page, and we have more and more actually that we can actually list. Therefore, those are some of the popular. Therefore, the popular ones you would have written HTML, JavaScript, PHP, and Dreamweaver. Those are actually so much popular. Therefore, then we can proceed to question number 2. List 4 ways in which a programmer can make program code easy to follow, 4 marks. Therefore, we have ways to do that, ways to make sure that a program is easy to read. Therefore, number 1, use of modules or short blocks of programs. You can make your programs to various small programs called subprograms. Then number 2, test formatting of reserved words. That is reserved words like input, output, read, write. You can use bold or you can use different colors to differentiate them from other codes. The next point, you can indent codes to make them readable. Now, if you look at look at this code, it has been very well written. This is called indentation. Look at how this code has been written by the examiner. This is called indentation. It is made that way for easy reading. Then use of comments or internal documentations. Now you can use non-executable statements inside the program code to make sure that whoever comes to edit your codes can know what you are doing. We call them comments or internal documentation. Then you can use blank lines to separate blocks of code statement. That is, in between one code and the other, you can skip a line. That is, use blank lines to separate blocks of code statement for readability. Therefore, those are some of the ways of making a program more and more readable. Then we can proceed to the next question. Draw a program flowchart to represent the following pseudocode. Therefore, we shall go straight and draw that one. Therefore, we shall launch a new Microsoft Word program. Then go to layout. Make sure that our layout is on portrait so that it can allow longer pages. Therefore, we shall draw the shapes that are supposed to be used. Therefore, we are supposed to use start. That one is a must to be used. Then make sure format is active here so that you can click and remove the color. Then you can get more here. Just go to flowchart, then we can go to flowcharts, then go to decision. Therefore you are making a decision somewhere that way. Then we shall also have some input that way. Then we shall have the one to read the scores. Read the scores, that is the input to read the scores. Then we shall have a bit of processing done here. Then another decision will be made. Then we shall have some output there. Then we shall have the end of the program. We shall have the end of the program there. The best one is to use, the best one to terminate is to use an or an ellipse, this one. Therefore, after doing that, we shall also have a decision, that is an output. We expect to have an output here, somewhere there. And then also we expect to have another output there. Then we shall have some processing done here. Therefore, the next thing is to remove this color. You just click and then go and click the design you want. Just to make sure that the inner color is not there. That is the blue color. Then we proceed doing so. Then the next thing is to put the direction. We need to put the direction of these flowcharts. That is the direction of our flowchart. Therefore, we go to insert shape. Then we take the arrow. Then you can draw the direction. Now we can go on drawing the direction this way. That one is very important, showing how the program is actually flowing. It is flowing that way. It's also flowing downwards towards this. Then from there, from this point here, this one we expect increments to be done from this decision. If our increment will be done from there, then we shall expect this one to go up that way. Then we expect it to this one to lead to come to this point. We expect this one to hit there that way. Then we also expect from this score here, from this point, we expect this one to go down. Of course, you would have used an arrow to show direction, that this one goes down this way. That way. Then from there we expect it to go and terminate. Therefore, from here we expect it to be very up to 10 this point here. Then it goes to terminate. Then from there we need now to write down. Therefore, we write as I explained. Therefore, we right click, just right click, add text, right click, add text, to make sure that when you go to these points, you will be in a position to add text without struggling. You just right click, then you choose add text, right click, add text that way. right click, add text, right click, add text, right click, add text. Then from there, now we can start our program as we explain it. Therefore, we shall have start. Then from here, we shall have to enter any score here, any scores. Therefore, you are entering any scores there. And here, we shall base it on that no records. No records found. If there is no record found, then it will exit. If there are any score, if there is that student doesn't have score, no records found, then it will just go down here and exit. And therefore this one is stop. For that one is for stop. Then we shall go down here. Therefore this one we have been told to initialize sum to 0 and also counter equals to 0. Therefore those are the two things that we are supposed to initialize, and we initialize them as process. Therefore, we are initializing counter. We are also initializing sum. Then from there, this is input. Therefore, we shall be reading read score or just input score. Now, since it has been any score there, you can just input score. Then from there, this is process. Therefore, you expect a process to take place here, and therefore sum equals to sum plus score. Then the next point will be counter. I can make sure that there is no space. Therefore, counter equals to counter plus 1. Now this is increment. Then these ones are supposed to be centered. Then after now having that, you have been told to capture more scores. Therefore, you shall have a decision more scores. Do we have more scores? More scores. Therefore, if no, then we shall actually, if there are no scores, that is, if condition is true. Therefore, if this point here, if there are no scores, therefore we shall go to this line. Do we have more scores? At this point, yes. If we have more scores, then we shall go to this point here and then compute the average. Average equals to sum divided by counter. That way. Then we shall print average and then repeat print average that way. Then we read again the score, that, or we read the score. You can use the word read here. We then read the score. Then if no, therefore this one we shall have now exit here. Now this one would have continued. Therefore, if there is, this is no, then it goes down here. That is if no. Insert shape. Now this one should be if no. If no results, then that one goes down. This one you just go to format, shape outline or outline. That way. Therefore, the flowchart would have been like that. That is start in scores, counter, initialize, read score. Then from here it goes to another point. There are more scores. Yes. Then we go to average, then print score, and then the flowchart again now proceeds. Therefore, it would have been like that. And therefore, more scores. If there are more scores, compute input next score. Therefore, for that matter, you would have also included something here. have seen something we have skipped. Therefore, we also need to have another input here according to the question. Here we need an input that is rediscover according to how the question is set. Therefore, we would have also gotten that one. Rediscover, then that way. Therefore, that flowchart is now complete, depending on how the examiner has explained how we are supposed to do it. Then probably some other student would also have drawn it otherwise, but there are many ways of actually doing the same thing. But for now, that is how that question was supposed to be answered. That is in 2015 KCSE. Yeah, that is in 2015 KCSE computer paper 1. Therefore, thank you very much for watching. Okay, see you next time. God bless you. Hey guys, I would wish to take you through 2014 KCSE paper 1 question 16. Remember, we have done 2015, 2016, 2017, 2018, and 2019. You can get them in the playlist containing this video. And it's important for us to note that question 16 is compulsory, and therefore answer question 16 and any other 3, but we are interested in question 16. State 2 advantages of using low-level programming languages, 2 marks. Then we have, other than flowcharts, state 3 tools that can be used to present an algorithm. Therefore, if you look at the expected answers, we can look at that advantages of using low-level language. Program execution is immediate, that is in low-level language. They require no compilation, no interpretation, stroke translation, hence they are faster. Hardware optimization is extensive. That means that the hardware is actually used to the last digit. Next, program developed tasks takes less memory. Therefore, in other words, you can just say that it takes less memory since program execution is immediate. It's also suitable for small devices like mobile phones and that's like watch, etc. They are suitable for small devices. It is also easy to design electronic device by use of low-level language since it is actually simply understood or directly understood by the machine. Then the next question, list tools that can be used to develop an algorithm that is other than flowchart. Therefore, you are not supposed to actually give flowchart as the answer, though it is there. But for revision purposes, let's include it. Therefore, we have decision tables. We have pseudocode. Then we also have flowcharts, though it was excluded. We also have DFDs. Also, we have ERD or entity relation diagrams. We also have decision trees. They are enumerated in book 3, and therefore those are the expected answers. You are just supposed to give 3. Therefore, there are so many there, but 3 was required. Then you can proceed to the next question, part C, and point of interest. This was 10 marks. A Form 1 admission interview consists of 4 tests: mathematics, English, Kiswahili, and science. In order to qualify for admission, an applicant must attain a minimum average of 65% in the 4 tests and not less than 70% in mathematics. All applicants must sit for the interview. Draw a flowchart that would read the scores for each applicant and determine whether an applicant is successful or not. 10 marks. Therefore, we shall just go straight to actually we have 1, 2, 3, 4 subjects. Therefore, let's go straight and launch a new Microsoft Word. Then we go to layout, go to orientation, make sure it is in portrait. Then after doing so, we go straight and draw the features that are actually required. Therefore, you're required to start our flowchart. Then you will remove the outline. We also need to have some of the input. Therefore, you have input. Then you can remove the outline. Then you have a decision. You have to make a decision somewhere. That is whether mark is less or equal to 70. Then from there, after having decision, we shall process the sum. That is the sum of the 4 subjects. Then we shall also process the average, though you can still process in the same box, but for clarity purposes, let's process them differently. Then from there, we shall make a decision of whether average is greater or equal to 65. That is, we shall have a decision there. Then after having the decision, we shall also have the output. Then after having the output, we need also to have 2 outputs of yes and no. That is not successful, then successful. That therefore we need to actually have the that one for the successful and the other one for not successful. Then from there, we shall have a decision for more input, that is for more applicants. Then once we have more applicants there, our program will terminate. Stop. Should use an ellipse and over. This is not a system flowchart but a program flowchart. Okay, therefore now after doing that, you need to combine as we explain the program. So first of all, we do the program. Then we go down. Then we also need to show the direction. This one, insert shape. Then you take an arrow that way. You also take an arrow to this one. Then from there, here we shall have 2 decisions. We need an arrow to be somehow that way. Then yes and no. Then from there we go on and also have that one as the arrow. Then we also that one. Therefore, first of all, we have drawn the structure. That is the structure of how our flowchart looks like. Therefore, from there we can now go on keying in. Therefore, we go back to our question. Therefore, we need to input mathematics, English, Kiswahili, and science. Therefore, our program will start. Then we input the marks. Therefore, start. You right click, then add. Then add. That is add text. Then we have our input. Therefore, we shall have input. We shall have our input. Enter English. Enter English. We are also entering Kiswahili. We are also entering maths and science. And science. That way, therefore those are our entries. Then after having that, we shall have our first decision. We have been told in order to qualify for admission, an applicant must attain an average of 65% and must have not less than 70% in mathematics. And therefore, our first option, we can ask ourselves, we can start by asking whether the person has scored 70, and therefore is math less or equal to 70. We put a question mark that way. Then this is our decision. Then if no, if our condition is no, here no, that is if our condition is no, if our condition is n, capital N, if our condition then you just go to format, outline, no outline, and this one should be capital letters, home, then you put it uppercase. Therefore, if our condition is no, then we proceed, right click, add text. Therefore, we shall have sum equals to English plus Swahili plus math plus science. Then down here we shall have the average. The average equals to sum divided by 4. That is the easiest way to do it. That since you have the sum, then the average is sum divided by 4. Then on the other hand, if the condition is yes, that is the student has scored less than 70%, then he or she should not be successful. Therefore, only successful that is no. On the other hand, another student would have used greater or equal to 70, but now this one, if we are using no, since math is less than that, that is math, let's go back to this, not less than 70 in mathematics in 4 tests and not less than 70%, all applicant must hit. Therefore, in order to qualify for admission, an applicant must attain a minimum of average this in the 4 tests and not less than 70. And therefore, for that condition, is maths should then be, this one should be yes. Yes. Is it less than 70? Should be no. No, because if it is yes, then the student is non-successful. Therefore, let's go on. Then we shall test for 65. Therefore, is average greater or equal to 65? Then you have a question mark. 65, not 56. Therefore, it is 65. Therefore, if the answer is yes, we go down. And therefore, insert shape. Therefore, you also check that condition, yes. Therefore, if condition is, just go to this point. If condition is yes, that is, if condition is yes, this one goes here. If the condition is yes, then what is given as output? Successful. Successful. On the other hand, if condition is no, that is, if the student did not attain 65 as average, then we give another point that not successful, not successful, and therefore if not successful, then this one goes the arrow. If it's not successful, you can go down, then you also go to this point here. Therefore, if it's not successful, then more applicants at this point. Therefore, we shall now get more applicants. For get more applicants. That way. Then we need also now to think of how will the program loop. That is how shall we go on and on getting the other students, that is the other applicants marks. Yeah, therefore we need to ask ourselves that way, how shall we now again loop the flowchart? How will the flowchart actually now move? That is to loop, to go back. And therefore, from this point, you will notice that after we ask for more applicants, then this means that our program must go back to the starting point. It must go back to the start. And therefore this one goes there. That is called repeat or looping. It will now, after from this point, the program will go back to the start. Then on the other hand, if a student has less or equal to 70, then that student is non-successful. That means that our flowchart again must again come to this point, to terminate to this point. You use this route that this student scored less than 70, and therefore the condition is yes, that the student is weak in mathematics, and therefore here we shall have yes. We shall have our yes there, and therefore outtrain, no outtrain. Now that means that our flowchart starts, then it gets English, mathematics. Okay, that is the 4 subject. It gets the 4 subject marks. Then it checks whether mathematics the student has scored less than 70. If yes, then the student goes this route of not successful. Then if it's not successful, then other candidates are actually gotten. Then the loop starts again to evaluate and that is the values. It will actually execute to this point. Let's edit here. That means if the student is not successful, then the program will come to an end at this point. Should look like that. Then on the other hand, this one should also successfully get more, should also go to this point. Therefore we shall have this heading to terminate to this end. That way, and therefore after the student succeeds to score more than 70, then his or her 4 subjects are calculated as total, sum is gotten. Then we go to the next condition and ask, is average now greater or equal to 65? Yes, successful. No, not successful. Then it goes down and it gets more applicants, and then the whole thing is now repeated. And therefore you're also supposed to indicate here repeat. Then you go to text direction and take that direction. Therefore we shall have repeat here, repeat, because it is actually a group, there are many students, and therefore it should look like that. And therefore that's how our flowchart looks like. It should look like that one. That is answering whatever we have been actually asked, that draw a flowchart that would lead the scores for each applicant and determine whether an applicant is successful or not. And therefore you can see what we have actually done. Therefore that's how the flowchart was supposed to be done, so that you can actually score 10 marks in the flowchart. Therefore, thank you very much for watching. Remember to subscribe if you have not subscribed. Also, see you next time as we shall be doing other papers, question 16.